Hey everyone, I welcome you all to the live session on Cloud Security tutorial by Intellipaat.
But before we begin the session, make sure to subscribe to our channel and also hit on the bell icon so that you will never miss an update from us.
Now let's see the agenda of the day. Firstly, we will begin with Introduction to Cloud Computing. In that, we will be explaining you the roles, building blocks, architecture, models, considerations, capabilities, and lot more. Post that, we'll be explaining you cloud security concepts like legal, types of risk, legislations, and compliances. We'll move on to forensic requirements and privacy issues. Post that, we will tell you the difference between contractual and regulated private data. Then we'll move on to what are audit reports and how to analyze it, followed by data discovery and its types. Then later on, we will tell you how to design and implement cloud data storage. Then finally, we will give you all the information about CCSP certification and also tell you how to clear it. So guys, this session is going to be very interesting. So stay tuned and watch the video till the end.
Let's talk about what exactly is cloud computing. What is cloud computing all about? Cloud computing is, as you're well aware, that it's an on-demand service, and it's something that you can get on demand anytime. It's available. You don't have to procure anything. You don't have to procure any hardware. The cloud service provider will do the job for you. All you need to do is, it's a self-service application. So you need to be logging into the cloud service provider's portal. So for example, if you're using Azure, you need to go to portal.azure.com and request for some service there. And based on what you want to set up there, you can get started. So let's talk briefly about the cloud concepts. It involves numerous complicated tasks such as understanding hardware requirements, buying required hardware, setting up the infrastructure, configuring the systems, and managing the system. So let's talk about all of this stuff. Concepts. So cloud as a self-service model. Generally, what would happen is you would go on to the infrastructure of the cloud service provider, be it Amazon. We're talking about well-known cloud providers: Amazon, Microsoft Azure, Oracle, Alibaba Cloud, Huawei Cloud, Yandex Cloud, IBM Cloud, Google Cloud, Tencent Cloud, and SAP Cloud. So these are probably the top 10 vendors when it comes to cloud computing. So for any application or for any organization who does not want to invest in their own infrastructure, does not want to invest in their own data center, they always have the option to set up their services on the cloud. Okay, that's what cloud is all about. And cloud is on-demand service. So whatever you request for, that will be given to you. Now we're talking about what was the scenario before cloud computing was available. Okay, so before cloud computing was available, deploying an application was a massive task. So typically, what you had to have was an organization needs to invest in a data center. In data center, you need to procure certain hardware like specific servers with a specific amount of configuration. And then you will set up your application on the particular server hosted in the data center. So you have to pre-plan a lot of things. Your planning needs to be precise. You need to know for the next 6 months or for the next 1 year, what is the expected amount of concurrency. When I say concurrency, the number of users who will be accessing the system, so the number of business users. Then we touch base upon the hardware requirements, such as the amount of RAM that is required to support this particular application, the number of CPU cores that are required to support a given application. So all those things are pre-decided. It's decided well in advance before you move on to the cloud. Now you see this. Prior to cloud computing, this was a massive challenge, because if you reach some limits, procurement of servers, procurement of data, availability, or procurement of further storage, they are time-consuming tasks. They take a bit of time. Now, with the advent of cloud, everything is available to you on you just need to click the option that you desire, and you will have that. That's exactly what they're talking about in this slide. Now, cloud computing involves numerous complicated tasks such as understanding hardware requirements, buying the required hardware, setting up the infrastructure, configuring the systems, and managing the systems. Now, we always think from customer perspective. Think about from the cloud service provider's perspective. Think about the moment Microsoft decided to roll out the Azure environment. So what are the things that they must have thought about? So they must have thought about what are the limits to their infrastructure as a service platform. For example, what kind of applications will be supported on the IS platform, what kind of services will be supported on the SaaS platform, what kind of services will be supported on the PaaS platform. So that distinction should become clear based on the organization's requirements and their processes. So once you have an initial understanding of how the organization chart is, how the things are rolled out there, you can then create this sort of architecture where you can state what are the underlying hardware requirements, buying the required hardware, setting up the infrastructure, installing operating system on those critical servers, configuring those systems, and then finally managing those systems. You have to buy all the hardware that is needed for the deployment, which can cost a lot. So if you're going for this, for the entire solution altogether, you will have to invest more. If you're going for a specific model along with something else, then the pricing can be lower down a bit. Also, we need to ensure that whatever hardware requirements we understood, whatever we are trying to buy, whatever is needed to set up our infrastructure, whatever is needed to configure our systems and manage the systems, we also need to remember that we have to set up the hardware that we have bought for our futuristic requirements. All of this needs to be accomplished before you can deploy an application. This requires significant investment of time, money, and manpower. What happens in the cloud world is the cloud service provider like Amazon or Microsoft, they have huge data centers. So they will lease their infrastructure. You need to deploy your applications there. Now, depending on the requirement or customer requirement, you may end up going with the PaaS model. You may end up going with IS model, and you may even go for the software as a service model. Cloud computing simply removes all the roadblocks you come across when you need to access some extra computing resources. To put it simply, cloud computing refers to the delivery of computing services over a network to a remote computer. Now, we need to understand, we need to differentiate between how things can be deployed on the cloud versus how things can be deployed if you're managing your own data centers and your own infrastructure. Now, the thing is, let's say on a given day, you feel that you might be having 8 gigs of RAM, okay, for your production server, and you have, let's say, 50 odd users. And in your logs, you see that CPU consumption is always high. And when you try to investigate the root cause, you were able to build, while you may not have had direct or specific proofs, but you came to eventual conclusion that by making sure that I increase my performance overall, the services can be delivered in a better way. So probably if what you see the trend now is that not only are we delivering services to the customer, but we are doing it in a diligent way, right? So which means that the performance aspect is also being taken care of. So we basically end up delivering computing services over network to a remote customer. Cloud computing also offers several advantages such as on-demand, scalable, elasticity, broad network access, measured services, multi-tenancy, and resource pooling. So on-demand scaling of computing power basically means that, let's say you have deployed a web application and the CPU utilization on that particular server is already 90% above. So you feel that your overall current memory is around 8 gigs in size. So now if you want to scale that to 16 GB, that should not take months or days. It's just a matter of minutes, and you can be onboarded onto a higher bandwidth. So it's doable. So this is why it's termed as being scalable, because you can always scale up from your existing hardware requirements to something bigger. So it's easily scalable as well. Now, anyone can access cloud computing services anytime they need to. Before cloud computing, anyone in need of computation resources had to buy these resources and configure them, which took a lot of time. Cloud computing allows you to increase the capacity of resources and services quite easily. This can be done by either horizontal scaling or vertical scaling. In horizontal scaling, we add more servers to our pool of servers. In vertical scaling, we add more resources to our existing services. So typically, when we talk about resources, we refer to resources as it could be a web application, it could be, if we talk about, it could be a virtual machine, it could be a storage device, it could be anything. And When we refer to scalability, it refers to either in terms of can you set up a similar web application in another region or in another data center? Can you increase the processing power or the memory allocated to a particular cloud server on demand? Is it doable? So that's what we are talking about. Now, cloud computing simply removes all of the roadblocks you come across when you need access to some extra computing resources. To put it simply, cloud computing refers to the delivery of computing services over a network to a remote customer. So think about a scenario where you have a single web server that is serving 100 odd clients at a given time, and every now and then you face performance issues. One way to resolve this problem could be that you bring on board another person, ask them to troubleshoot the same issue, and depending on the requirement, they may have a recommendation where they may say that in this case, more resources, or you may need to further scale up, right? The best part about cloud computing is that it is available on demand. You can pick up a time frame if you feel that you're facing certain roadblocks with regards to your existing cloud infrastructure. So you can always scale up on demand. You can set up either auto scaling properties to scale up your services on demand. So one of the key aspects is that of cloud is served on demand. It is scalable, it is elastic, provides you with a broad network access. It offers you a multi-tenant platform. Resource pooling is also available. Point is, anyone can access cloud computing services anytime they need to do so. Before cloud computing, anyone in need of computation resources had to buy these resources and configure them, which took time. So we are talking about legacy technology. So what was the scenario prior to the cloud, before cloud came into picture? So typically what would happen is an organization would have multiple system administrators. The system administrators will troubleshoot your systems. They will give you some level of access depending on what is your job role and what is the requirements. And accordingly, in future, for futuristic purposes, you may need to scale up those requirements or you may need to scale down those requirements. But the whole idea is that it gives you the platform where you can deploy certain services, and if you feel over a period of time that you need to further scale up, so then you can also go on to that path as well. Cloud computing allows you to increase the capacity of the resources and services quite easily. This can be done by either horizontal scaling or vertical scaling. In horizontal scaling, we add more services to our cluster pool of clusters. In vertical scaling, we add more resources to our existing servers. So vertical scaling is all about adding extra memory or adding extra CPU power. So you can see that you can scale horizontally as well as vertically. Elasticity, cloud computing services are available to be accessed anywhere using the internet. You do not need to be on a special on-premise network to access these services. So it is elastic. You can either, depending on the customer requirements, you can scale up the resources. You can also scale down when there is low traffic. So that will give you added benefits. In terms of cost, being elastic is, elasticity is a property that can really help you. You can either scale up or scale down depending on your demand. When we talk about scaling, we talk about adding more processing, either vertical scaling or horizontal scaling. In vertical scaling, we talk about adding more capacity to an existing system or to an existing server. In elasticity, right? So that is horizontal scaling. In vertical scaling, we talk about adding more and more servers. Now, elasticity refers to a situation where, depending on your requirements, you may either increase the demand, you may add more resources to serve existing users, and if the demand falls short, you can also further scale down. So that's a difference, right? In scalability, we are always talking about scaling up. We are not talking about scaling down. Elasticity refers to both the areas. You can scale up and scale down. So it refers to both the concepts. So the thing is, when there is no demand, probably what you will be doing is you will be running your resources. So you have two options there. If there is lack of demand for anything, you might continue to run your main services for the sake of business requirements, and you may shut down some components if they are not needed. But if they are needed, you can further scale up. So it purely depends on what your end requirement is. Cloud computing allows you to increase the capacity of resources and servers quite easily. This can be done by either horizontal scaling or vertical scaling. In horizontal scaling, we add more servers to a pool of servers. In vertical scaling, we add more resources to our existing servers. Broad network access. So here, cloud computing services are available to be accessed anywhere using the internet. You don't need to be on a special or a on-premise network to access these services. All you need to make sure is that even if your home IP address keeps getting changed, because no IP address is anytime static, right? So even if your IP address keeps getting changed, the whole idea is that your current IP address should be white listed at the security layer. Cloud computing roles, let's talk about it. Now, there are four main cloud computing roles which we need to be aware of. We have a provider. We are talking about Amazon, Azure, Google Cloud. All of these are providers. And then people like us who can be potential customers. So we may end up deploying some service on the cloud. So we become the consumers or customers. At the same time, an organization might be very big in size. So they may have some of the sales partners who will drive the show on behalf of their providers. So probably it could be any partnership between Microsoft Azure and one of their partners. So in the case of unavailability of a Microsoft resource, they can take charge and provide relevant services. Okay. So the cloud provider, we are talking of IBM, we're talking about different cloud providers. Customers could be people like us, right? Our organizations, if they want to get onto the cloud platform, so we become customers. Now, so partner would be somebody like, here is a good example, okay? Now we'll talk about Thales and Azure, right? So Thales and Azure, they are basically partners. Thales is an organization that provides cryptography services using hardware security modules. So typically you would deploy a key vault or a key storage management kind of a thing to encrypt your keys and provide centralized storage of the keys. Now, sometimes you may need to refer to an external provider, right? So if you are under the impression that your storage keys are also being managed not only by the cloud service provider, but they also have access to your encryption keys. So there's a potential risk that somebody can come and somebody from the cloud service provider can come and decrypt your keys, which is pretty likely, which can happen. So that risk is always there. Now, to avoid that risk, you can deploy something like a hardware security module. This is nothing but a specialized service provided by external providers who can generate the keys on your behalf, can manage the keys on your behalf, and they are outside the purview of your cloud service provider. So the cloud service provider doesn't have the access to manage those keys. Now, in case of Microsoft Azure platform, they have partnered with Thales. Thales is the organization who has that expertise to create cryptographic keys, manage them on behalf of their customers. So they have that expertise and they provide this kind of thing. So what Azure did was partnered with Thales to provide this kind of a platform. That's a partner. Now, broker service, we're talking about CASB and we're talking about or SASE platform, right? So cloud access security brokers. Now here, now what are examples of such brokers? We're talking about CASB providers. You could say Netscope is one good example of that. Then you have Versa Networks. That's another example of this. Then you have Cato, which is probably the best example of all of them. Now the point here is that all of these are CASB providers. So what they do is, let me give you an example. So for instance, let's say you guys are sitting from your home and you're trying to access an Azure web server, right? Now the thing is, you are sitting, now we are all operating in pandemic times. We are trying to access the web server from our homes. So if we're trying to access this from our homes, probably we need a safe way of accessing it, right? You may have the ability to reach to this web server directly, but from a security landscape, it is lacking those features. So what we will do is we will connect to something like a POP, which is called as point of presence. So this connection between our home to the cloud service provider's location, that's a WAN service, right? Our packets are traversing the wide area network to reach the corresponding data center. So the problem here is that the WAN service is unreliable. Some packets may be lost. They need to be retransmitted. So we will face all those kind of challenges. Now, to get away from that kind of a thing, what happens is companies like Keto Networks, what they're doing is they're providing with you their private backbone. So what happens is if a user is, let's say, sitting here in India, and let's say there's another user sitting somewhere in Singapore, right? Now, to me, it doesn't matter whether the user is sitting in India or the user is sitting in Singapore. What matters is that they should be able to connect to a private backbone channel for fast connectivity to my web server. So this guy sitting in India also wants to access the web server. This guy sitting in Singapore also wants to access the web server. So to enable fast connectivity, what I will do is I will connect each of my clients in a particular location to a specific provider. And from the provider's interface, you will then further connect to the actual service provider's interface. And that's how you get this kind of a facility. So it doesn't matter whether the user is sitting in India or the user is sitting in Singapore. They will connect to their nearest point of presence server, POP. POP is a term very widely used in SASE or CASB platform. And once the user is connected here, their systems will be subjected to a lot of reviews. So you will check out for things like next generation firewall features. You will check for IDS, IPS, the TLS protocol version, and so many other things. So when we talk about SASE platform or the McAfee solution, it's a secure way of connecting from your home to your corporate systems. That's a broker service example. So you can see here, provider is somebody who provides cloud computing services for sale to third parties. Then you have a customer. Customer could be anybody like us who purchases cloud computing services from another one or more providers. Partner, third-party companies that offer products and services that interact with the services offered by a cloud service provider, examples, service monitoring. And then finally, you have the broker who manages the cloud services, negotiates the relationship between cloud providers and cloud consumers, and also provides that security landscape that is needed. Now, to understand cloud security, what is most important is that we understand the basic building blocks of cloud computing. These building blocks are nothing but the infrastructure services that make up the various cloud computing platforms. Let's talk about all of this. Now, the building blocks are the compute service, the storage service, the networking service, the database service, and the orchestration layer. Right. Now, the compute service refers to the creation, management, and usage of virtual servers through which we can perform any computational tasks. These virtual servers can then be used by users to offload some resource-intensive tasks such as calculations or application deployment. Example, your Amazon EC2 instance. For example, if you have set up a dedicated web server on the Amazon EC2 instance, it's an example of nothing but the compute service. Now, in cloud computing, storage is broken into two categories, the block storage and the object storage. Now, what is block storage and what is object storage? Now, let's say if you have set up an Amazon EC2 instance, let's say it's a virtual machine. That virtual machine does not just work in isolation, right? It needs to save some data, at least the whatever data that is needed to boot up that system. So it needs to save some booting data in some of the locations, right? So block storage is nothing but the storage volume that is attached to the virtual servers. Very simple example of that. The object storage is something which abstracts the file storage and management. All these details are handled by a cloud service provider. All we have to do is upload and access files. Now, see, the thing is, for a moment, go back to the infrastructure as a service platform. Now, the moment you set up a web server, does the web server just work in isolation? The web server needs to have other components, like it needs to have certain permissions enabled. It needs to have some sort of space available to store some kind of data, like some of its own data, some of it relevant data, right? So you need block storage to store some data that resides on the server itself. And then is the object storage, where that's a location where you can dump any kind of data. It's cost effective, it's cheap, and you can dump large amount of data in object storage. And then you have the networking layer, So in cloud computing, networks allow users to connect several systems together in cloud. Networks in cloud are highly virtualized to provide a high degree of flexibility in designing their networks to suit their own unique business requirements. So in cloud computing, everything is virtualized, right from storage to networking, everything is virtualized. Databases. In cloud computing, users may choose to either build and manage their own database servers on top of the existing infrastructure provided by the cloud service provider. However, it is more practical to use a managed database service in which you specify your preference, example, database vendor, server capacity, version. Best example could be AWS, relational database service. And the third point is managed database support, where managed databases support various kinds of databases, which makes them more flexible than self-managed database servers. So that is on the databases. Now, databases can come two forms. You can leverage SQL as an example, SQL Server on Azure versus SQL Server database in an actual data center. There are two different things. So one is the example of PaaS, and another one is the example of IaaS platform. Orchestration. Orchestration refers to spinning up and managing cloud computing resources manually can get extremely difficult. Cloud orchestration allows us to create automated workflows for creating and managing cloud environments. Using cloud orchestration, we can quickly and easily create cloud resources, shift operations between environments, and perform various other administrative tasks. Orchestration refers to spinning up. So let's talk about that. Spinning up and managing cloud computing resources manually can get extremely difficult. Cloud orchestration allows us to create automated workflows for creating and managing cloud environments. Using cloud orchestration, we can quickly and easily clear cloud resources, shift operations between environments, and perform various other administrative tasks. I'll give you a good example of this orchestration. Let's say you have set up a data warehouse, okay? Let's say you've set up something called as Azure Synapse Data Warehouse, okay? It's a data warehouse cluster. Now, the thing is, running a Azure Synapse Data Warehouse 24/7 is going to cost your organization a lot. So what you want to do is, your business requirement is that my Azure Synapse Data Warehouse should run for 12 business hours only. The whole idea is that I want to run the Azure Synapse Data Warehouse at a time during the business hours of the day, right? I don't want to run it at night time. So if that is a requirement, then the problem is that can you Azure Synapse Data Warehouse cluster is nothing but a PaaS service. Okay, it's a platform as a service, right? So here, can you set up alerts? And by doing that, is there a way by which you can start and stop your Azure resources at a given time? Is there some facility that gives you the ability to schedule jobs and to start a resource at a specific time and to shut it down at a specific time, right? That's the whole idea. So while you cannot have a cron tab entry for a PaaS service, that's not possible. But you can use something called as Azure automation, right? You can use that to schedule administrative tasks such as starting and stopping a PaaS service like a Synapse Data Warehouse, right? And that way you can define certain jobs similar to this. So by doing that, you don't have to every time log in manually and start and stop your Synapse Data Warehouse cluster. You just schedule this thing via the Azure automation workflow, and this can be managed in a seamless way. That talks about compute, storage, networking, databases, and orchestration. So it is important to note that these are not the only services offered by the cloud computing platforms. However, all other services offered by cloud computing are usually built on top of these services. Now let's take a look at the cloud architecture. The ISO, International Organization for Standardization, published a cloud reference architecture in their document ISO 17789. This document lays out a common terminology framework that assists different parties in communicating about their roles and responsibilities. So in short, this particular slide simply says that how you have ISO 27001, which talks about an information security management system. Similarly, you have ISO 17000 789 that references the cloud reference architecture from a security perspective. Now, here in the reference architecture, there are several activities which are performed in cloud computing, which are broken down into 4 layers.
Just a quick info, guys. Test your knowledge of cloud security by answering this question. Which data may not be suitable for public clouds? A. Legacy application data. B. Mission critical workloads. C. Sensitive data. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Plus a set of functions which spans across the layers. These are user layer, access layer, service layer, resource layer, and multi-layer functions. The user layer is a user interface through which the customer interacts with the cloud services, performs customer-related administrative activities, and monitors cloud services. A good example of that would be somebody logs into portal.azure.com, tries to access based on their defined role. Let's say they have read access on some resource. They should be able to access that resource. Let's say if somebody has access to Azure Security Center, which basically gives you a blueprint of all your security active. From a security standpoint, it tells you how compliant you are with the various standards, right? So somebody can have access to the Azure Security Center. That's just an example. The whole idea is that every user is given some sort of access. So what they will do is they will log into the portal, and from there they will start accessing those respective resources. Then you have the access layer. The access layer provides a common interface for both manual and automated access to capabilities available in the service layer. Now, for instance, somebody goes to portal.azure.com. Okay, let's assume that we have set up a web server, and now the requirement is that I need to access this web server, but I need to do it in a secure way. So what we're talking about is this. I have a web server. Now my web server has a private IP address, right? So let's say the IP address of my web server is 10.10.10.15. Okay. Let's assume that the business requirement is instead of somebody accessing the web server directly via the public IP address, we have disabled that. And I want everybody to be accessing my web server using my private IP address. Now, the catch is if the moment you go onto the browser and if you type in this particular IP address, probably it will not be visible to you. So let's assume that I'm trying to access my web server, let's say 191.168.10.2. Now, this is a public IP address. Now, instead of something like this, right? If I type 10.10.10.15, this is a class A private IP address. So definitely your web server will not be visible via this, right? So the question is, how do I make my users access the web server using a private IP address on Azure? What we will do is, so one of the options that I'll talk about is, so let's say I go on to portal.azure.com, okay? What I would do is, if I want to provide somebody with that kind of a thing, I will set up virtual machines. And there, basically, I would have a Bastion host service, Azure Bastion host. So from a Bastion host service, what will happen is my user will RDP, will do a remote desktop to a particular machine. And from there, the user can then go from there to portal.azure.com and then can access any specific application, right? So the first thing is the user will go to portal.com. If they have set up Bastion host, which is like a VM service running there. So once you click on that start and once you log in there, you will automatically do a remote RDP. And from that RDP session, then you can log into portal.azure.com and you should be able to view the content via the private IP address. Now, what is a service layer? The service layer contains the implementation of the services provided by a cloud service provider. The service layer contains and controls the software components that implement the services. Then comes the resource layer. The resource layer is where the resources reside. I think this is very simple. For example, your PaaS service, such as your PostgreSQL database on Azure or RDS on Azure. So they are pretty much examples of this. Now, the resource layer is where the resources reside. These include hardware such as servers, networking switches, routers, and storage devices, and software that runs on the hardware such as host operating systems, hypervisors, etc. Now, don't get confused by this definition here. The notion is very simple. If you are running a PostgreSQL or a MySQL database on Azure, which is a PaaS service, now to you it is, you are getting the graphical interface, you are getting everything over the web browser, but somewhere that virtualized system is getting installed, it's running on a physical server somewhere, right? So you are getting access to that somewhere, right? So eventually on the top of the hypervisor, you are getting a layer from where you can access this system, but eventually at the physical end, it's getting installed somewhere. And the final is the multi-layer. Multi-layer functions include components that interact with the functional components of the above four layers to provide supporting capabilities as integration capabilities, development support capabilities, etc. So these are all the examples of the cloud computing. Now we'll talk cloud service capabilities. Now there are different types of capabilities that we acquire using cloud services. So we have application capability types, we have the platform capability types, we have the infrastructure capability types. Now, easy examples of this application capability, setting up a, like for instance, you set up Azure web app. Azure web app is nothing but a web application hosted on Azure platform, but it's offered as a platform as service. Now here it's a ready-made application. You don't have to install IIS web server. You just have to check out for Azure web app. Just go to the Azure marketplace, just go here, create a resource. Maybe you can just search out any of the things like Azure web app, right? Something like this, right? So you can always go ahead and deploy that. This web app, this is the web app, right? So you can go ahead and deploy this kind of a web app, right? This is what I was talking about. Create a resource, you get an Azure web app, okay? Platform capability. So for instance, if I want to deploy database without installation, right? I mean, I just want to utilize a quick deployment. So for example, if I want to deploy PostgreSQL database, I can deploy that. And if I want to deploy a virtual machine or a Windows server directly and then deploy something on the Windows server itself, that would be in the infrastructure capability part. Okay? So application capability types, the definition, there are several applications that are offered used by cloud service providers such as Outlook Mail, Google Drive. Mind you, even your OneDrive is an example of it's a cloud application, right? Platform capability types, there are cloud services that offer us pre-configured platforms to deploy and manage our own applications, example such as AWS, Elastic Beanstalk. And then infrastructure capability types, there are cloud services that offer us basic infrastructure tools such as server, storage drive, which we can configure and use according to our own needs. So for instance, if you want to deploy specific services, you can go ahead and deploy an Azure virtual machine. You can deploy a Windows server. You can go ahead and deploy a Ubuntu virtual machine or a Red Hat virtual machine. Depends on what you require. And on top of, once you have installed that, you can deploy anything further on top of that operating system, right? So that's an infrastructure capability service. So then I can deploy an Apache web server. I can deploy a database server, I can deploy any XYZ kind of things. Let's take a look at the deployment models. Now there are 4 deployment models. We have the private cloud, we have the public cloud, we have the hybrid cloud, and we have the community cloud. Let's talk about all the 4 of them. So private cloud, basically we refer to that as a cloud computing infrastructure created by or for an organization for their own internal use. Now a classic example I'll give you. Now Citibank actually hosts their own infrastructure. Right now, they're not at all on any public cloud platforms. They have their own infrastructure, they can manage all of that. But what they have done is they have set up something called a City Cloud, right? Which is nothing but it's a portal where a lot of development servers for different development servers are set up, right, for different applications on VMware. Okay, so they have set up this up on VMware ESX platform, and they're happy with the setting up development servers there, right? So when it comes to their UAT and production, they are all bare metal. When I say bare metal, they are all dedicated physical appliances. For the development servers, they have just virtualized it using the VMware. So it's their own cloud platform. So that's a norm. So the specific applications like Citibank's Genesis, it's a well-known platform they use for mortgage or for wholesale, platforms, in Genesis, they are using the development servers. For example, if they're using Cyber's database for a lot of transaction processing or subscription processing, so there they are using a lot of development servers running on VMware ESX platform. So that's a private cloud for you. That's a particular organization's own cloud. Then we have the public cloud, which is a model we are more familiar with. Organizations build massive infrastructures in their data centers and allow any user to pay and use resources that they need using virtualization. So simple. All the well-known, let's talk about the top 10 vendors, right? Top 10 would be Amazon, Azure, then we'll talk about Google Cloud, Alibaba Cloud, Huawei Cloud Platform, Tencent Cloud, Oracle, then IBM Cloud, 8 vendors. Yandex Cloud probably would be the ninth one. And then what? SAP Cloud, right? SAP also has their own distinct platform. Now, they are all examples of public cloud providers. You can deploy your applications there. The thing is that they have massive data centers around the world and they are leasing their infrastructure to potential customers. So if we as a startup or we are an organization that don't want to invest into infrastructure, I think we can use the rental services provided by a cloud service provider to host our applications on their infrastructure. So that's the classic definition. This is a model that we are very, very familiar with, most of us. Now, hybrid cloud is a mix of scenario where an organization will use both the cloud services. So they will use private cloud for data sensitive operations and public cloud for operations that do not have these concerns. So the definition of hybrid cloud doesn't end just here. A simplest example of hybrid cloud would be like this. Let's take an example of a company like Motorola. Right? Now, Motorola will be running their services. Now, the catch is that they may have their own data centers, but for the core applications, they probably, given the scenario that we are right now in these times, probably they may not want their, so let's say they want to invest in their DR. They want to set up their disaster recovery infrastructure, okay? But they probably may not have the resources or the needs to, set up their secondary DR. So what they do is they decide, hey, let's not jump the gun. Let's get on to let's host our DR services on AWS. So while they have their own infrastructure, if something happens to their infrastructure, they can fail over to the AWS to the AWS platform to make sure that the impact is minimal to the business users. So, they have a way to provide this capability. Now, this is a classic example of hybrid setup. Now, why? Because they may probably have their own cloud where they are virtualizing their platforms. But however, for DR requirements, they probably, because they are having a single data center, they want to, and while they have virtualized their different applications, they probably want to go to AWS for building a resilient architecture. So they leverage for DR services, disaster recovery services, the public cloud provider, and for their own infrastructure, they are built up a private cloud. It's as simple as that. And then you have community cloud. Here, multiple organizations form a consortium to build a cloud infrastructure, which is then available to be used by only members of that consortium. So here, it's a very simple notion. Many organizations will form a consortium to build a cloud infrastructure platform, and only the members of that consortium will use those services. Let's talk about cloud service categories. Now, there are 3 deployment models. I think this is something we are well familiar with. We have the SaaS, PaaS, and IaaS. Let's talk about each one of them. SaaS stands for software as a service. Here, users can use an application provided by cloud service provider and pay for its use. Now, my organization we are using the Google Suite, G Suite platform. So we use Google Mail for business activities. So we are using that serves. At the same time, we are also using Office 365 for various services, right? So we are using that for our, opening our Word, online Word applications and so many things, right? So that is SaaS platform.
Just a quick info, guys. Intellipaat provides CCSP certification training, mentored by industry experts, the course link of which is given in the description below. Now, let's continue with the session.
And then we have the PaaS. PaaS stands for Platform as Service. Users can get a managed platform where they can deploy and run their applications without the developer worrying about the server management. Example, Heroku. You get another example could be Amazon RDS. Finally, the IS platform. Here, users can purchase basic computing resources and use them for their own needs, like AWS. Here in IS platform, you would properly deploy a virtual machine with a operating system and then utilize it for your specific requirements. Let's say if you want to have more fine-grained control. So for instance, if you deploy Azure Web Application, which is a PaaS service, there you can define only specific configuration settings. But if you want to have more fine-grained control, probably what you will do is you will define, you will set up a Windows server machine, virtual machine. On top of that, you will install IIS server, web server, and define control some settings there, which will, by doing that, it will give you more control than the Azure Web App, PaaS setting. Shared considerations. There are several cross-cutting or shared considerations that are addressed in the cloud reference architecture. These are interoperability, portability, reversibility, availability, security, privacy, resiliency, performance, governance, maintenance, versioning, SLA, auditability, regulations. Now, it's a very simple thing, okay? I will just put it in one single line right now. The whole idea is that this is something, all these pointers, whether it's things like regulations, privacy, the chance to audit something. See, the point is, the moment you move towards the cloud, okay, we are on a multi-tenant model, more or less, right? That's the more appropriate consideration. So probably, for instance, let's say my organization sets up a subscription, uses a subscription account on Azure and sets up their services in the Azure Ireland data center. Now, the point is that maybe I'll be setting up my Azure database, PostgreSQL database, my web application, everything on that data center, which makes sense. Now the catch is, once we are shifting some gears there, right? What are the things? Every organization has certain governance policies. It could be from InfoSec standpoint. Now, I serve as a CISO in one of the organizations. I can tell you that you define policies such as your data security policy, your disaster recovery policy, your cybersecurity policy, like what are the do's and don'ts, how for an organization, so if you are using emails, what's the right way to use emails, all those kind of things. Now, the moment you shift your applications towards the cloud, it's a real shift, right? A lot of things can change there. Now you're no longer in control. Whatever model you go for, whether it's IaaS, whether it's PaaS or SaaS, whatever it is, you are no longer in control of your own data. Your data is residing, and it's residing at the discretion of the cloud service providers infrastructure. So for instance, you may have a policy that says that you want to reserve all the logs for 3 months. You're keeping at a bare minimum 3 months for audit perspective. So if you want to trace back any transaction, any suspicious transaction, so there you may preserve that for 90 odd days. Now you deploy your application quickly onto the cloud. Now these semantics can change there. Now probably the web server on the Azure platform, they're just keeping the logs for probably for 7 days. At a max, they may keep for 30 days, but not beyond that, right? So even if you talk to them, it would not generate much traction because that's the maximum you can get because you're on a multi-tenant model, right? So certain nomenclatures can change. The other thing could be, for instance, a year back, I got a chance to review the security posture of Cooper Surgical, which is a healthcare company which is based in the United States. Now, obviously, they were first moving to the Azure platform last year. And interestingly, they were onboarding their global sales team was actually onboarding their applications, certain applications in Japan and certain applications in Denmark and certain applications obviously in Texas, in the United States. So interestingly, the database, which was Azure Synapse Data Warehouse, which could load a lot of data, they were uploading the Denmark data there as well. Now, what was surprising is that they were left unaware that obviously, first of all, the HIPAA regulation, would come into play. GDPR regulation will come into play because if there is certain PII data of certain individual sitting in Denmark, right? How can you load it to a database that is residing in a data center in the United States? And the same would go for Japanese data. So if you want to, deploy, or if you're storing, there is no way somebody will stop you from storing Danish data on a database that resides in United States data center in Azure. As an organization, that is your responsibility. It is not the responsibility of the cloud service provider. So there are certain shared considerations. So in this case, there were certain violations of the HIPAA compliance, and maybe there were certain violations of GDPR compliance as well. Because as per the privacy regulations, the data of if there is certain PII data of a European individual, it should be within the boundaries of Europe. It should not go beyond that. So these are certain, and especially because the services can be deployed so quickly at the end of the day, who are working behind the scenes too. So for instance, who would be that person who is going to load the Danish data or the Denmark data in an Azure database that actually resides in, that was actually hosted in US East Coast? So probably it would be a DBA. That person probably will not be aware of the data privacy regulations, and this is an area of concern, right? Boundaries, and while there are certain responsibilities of the cloud service provider, certain responsibilities will also fall under the purview of the cloud customer as well. So there are certain shared considerations. When you talk about SLA, service level agreement, what's the norm around worldwide? Because you can deploy so you can get started so quickly on the cloud. What's been observed is 7 times out of 10 there is a de facto norm, and what's been observed is that mostly cloud architects would end up going quickly deploying. If an organization wants to grow on the cloud, they will plan quickly and move, and very soon they will be able to set up their resources on the cloud. Now, while that's a good thing, what's lacking is that every cloud service provider provides a generic SLA, service level agreement, on their portal. And many times, the cloud architects who deploy such services for their companies, they end up not reading the service level agreement. And later on, the same organization which deploys their services on the cloud, now they are facing certain challenges. For example, their policy was to make sure that the logs for forensic investigations, the logs are preserved for 3 months. Whereas on the cloud, it is just preserved. I'm just giving as a use case. Maybe it's preserved for, depending on the provider's maximum and minimum, logging requirements. Maybe it is preserved for just a month. So in that case, probably they will be found lacking, right? So it is important to read the SLA. Now, there are certain questions, I believe, from the audience. Let's take a look at all of that. So let's touch base quickly upon all of these pointers. I think we talked a lot about this thing. So what is interoperability? It's the ability of 2 or more cloud services to work with each other and exchange information. Portability is the ability to move data and operations from one cloud service to another with minimal disruption. Reversibility is the extent to which cloud-based applications are designed so that they can be moved to other cloud providers or environments. Now remember, there are a couple of things like vendor lock-in. Now, if you go on to RDS or if you use DynamoDB, there will be a vendor lock-in kind of thing. It will be hard for you to, if you feel that AWS is more pricier or it's more costly, and let's say you want to move to a cheaper alternative like probably like Oracle Cloud, or for a matter Alibaba Cloud, which will be a lot cheaper. So that will be a bit hard, right? Because vendor lock-in will come into play. So you got to be very clear when you deploy certain things. You also got to keep that aspect into mind, where if things don't go as per the plan, or if you feel that the services that a particular vendor is offering a lot pricier, and if you're not getting that, it's not meeting your expectations, you should have the ability to fall back on another vendor, right? So that is an important aspect. So, the whole idea that we're talking about, all these shared considerations, many of these are governance related, right? Also, they are business related aspects as well. The whole idea is that the moment you deploy a service in cloud, does your cloud administrator or your cloud architect, do they think about all these aspects before deploying something? 8 times out of 10, or probably be more aggressive here, I will say it's, I'll be more bold in my statement. I'll say it's 9 times out of 10, they will not think about this. So that there's a 1% range of architects or professionals who will, prior to deployment of any service, because it's so fast to deploy, it's all self-service. Before you deploy anything, you will not be thinking about short-term plans, but also the long-term consequences. If tomorrow, if you're not getting the right returns, you should have that pathway to switch to another provider, not just get locked in just with one. Availability is a very important thing. In cybersecurity, we talk about the CI triad: confidentiality, integrity, and availability. Availability is probably one of the most important aspects. It determines how much uptime can be provided by a cloud service. I give you an example. If you go to a site like Down Detector, you got to be well aware of the fact that a provider like IBM will have a lot of outages. So it's better off not to go with them. You're better off to go with any other vendor. Maybe like, if cost is a concern, you can go to Azure, or maybe for that matter, you can switch on to Oracle Cloud, where you will get a better service. You can at least get a better service than these things. Now, there is another aspect also. When we talk about, I'm not just talking about all these components, but I'm also talking about something in addition to this. Now, you see, this entire cloud world is governed by two things, right? And especially in the last 2 years of the pandemic, we have seen more of this happening. Now, what exactly we're talking about? We are talking about the cloud service CSPs, the number of data centers that they have, right? So in the last couple of years, what has happened is Oracle has been very aggressive. They have rolled out their cloud certifications free of cost. Even right now, their cloud architect and all those certifications are free of cost. They were last year and a half back in May 2020, they also made this free of cost. That's just to gain traction and more visibility, because they are lagging behind in this space. And in last 2 years, they have launched a lot of data centers. In 2019, interesting development happened, right? Oracle and Microsoft Azure, they're pretty much competitors in their own right. They signed an agreement, and now they are partners. Now, which means in a region where Oracle is based out of Redmond. So assume that Oracle doesn't have a data center in one location, right? They have one in Ashburn. Let's say in Seattle, Azure has a data center. So now Oracle customers can actually they can leverage the Azure because of this partnership. They can also utilize the Azure data center internally for faster access and all for better response times. So this engagement has also happened. Now, that's probably one of the only exceptions. You can read about this. You can go to Oracle and MS Azure 2019 partnership. As simple as that. They expand interoperability, right? So Oracle Cloud Infrastructure and this. So that's the kind of partnership, So I'll just share the link with you. You guys can probably get a chance. You can go through it. Oracle is probably the best database around the world. I've worked a lot with Oracle. I do agree with that. Right? So in terms of performance, in terms of resiliency, it's probably one of the best, but it also has pricing. So AWS outage just recently took down Netflix. That's right. That just happened. So these things can impact a lot of customers, like Netflix, such on-demand service, pretty much real time they operate. And if it's equally important to assess whether you should be on the hybrid cloud, whether you should run what kind of workloads should be you set up on the cloud. That's something you as an organization want to take a look into that. Third-party service providers, outages will happen. They may be resilient, but the point is that these things may be beyond your control, right? So if there is a region outage in Azure, and if let's say there's a customer who is completely dependent on them, their business is at the mercy of the cloud service provider. At the very best, they may have set up a regional DR service by which most likely that coverage will be provided. So AWS market share is multiple times higher than other CSPs, and the impact of outage is also higher. Now, data privacy is a very ambiguous topic, right? Because I deal with data privacy inside out, and all around the world, you are seeing the federal governments around the world are tightening the rules regarding data privacy. Very strong. You have PIPEDA in Canada, you have CCP in California. There are multiple other regulations like HIPAA, that provides from a healthcare perspective in the United States. There are certain NIST regulations. You also have data privacy laws, very stringent laws in Singapore market, very stringent laws, very hard laws in China. But what's the interesting anecdote to this part? So while
Just a quick info, guys. Test your knowledge of cloud security by answering this question. Which data may not be suitable for public clouds? A. Legacy application data. B. Mission critical workloads. C. Sensitive data. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
all this setup is there, GDPR, CCPA, PIPEDA, other regulations around the world. The interesting anecdote to this part is there are some anti-privacy laws also around the world. And I'll give you a good example of that. Okay. Now, there is something called as Cloud Act. Now, this Cloud Act doesn't really deal with cloud. Okay. It's a different act altogether. It basically supersedes the Stored Communication Acts of 1986. So it's an update to that act, right? So the clarifying lawful overseas use of data act or a cloud act. And this act created a lot of furor in United States somewhere in 2016, 17, around that, maybe around 2017, 2018 period, right? That was, now the problem was, this was a case, there was a federal case against or there was a lawsuit filed between United States government and Microsoft. The US government wanted access to one of certain emails that were originating from Ireland, right, in the Azure data center in Ireland, right? So there were certain concerns around that. However, at that point in time, there weren't any regulations that could compel Microsoft to provide something. So as a result of that fiasco, or that of that fiasco between Microsoft and US, the Donald Trump's regime, they actually ended up, the government around that time in US, they basically introduced Cloud Act, which simply says this part, which compels the only US-based technology companies via warrant or subpoena to provide requested data stored on servers, regardless of whether the data are stored in US or in foreign soil. Now, this is a complete anecdote to GDPR, right? So if now tomorrow there is a situation where any other US company, let's say Amazon or any other firm, and when they want certain data of an individual based in Europe, okay, this part is an anti-privacy law in a way. So while you have certain pointers, so you may be found wanting it, because this is just one act, okay, by the way, okay, and this is, to be honest, this is very well drafted act, right? The moment you look towards, the moment you go towards China, right? If you, without any bias towards any country, this is all, every country have their own rights in these things. China has such anti-privacy laws. So while at one point they really want to control that part, if you're working with a client, Chinese cloud service provider, and especially if you're hosting a website with them, you've got to be very careful with that, right? Sometimes you can end up getting a bad taste. So it's very important to be aware of any such anti-privacy laws around the world, right? So while there will be some privacy laws that will force you, there are equally there is a lack of awareness amongst people regarding this. In the Middle East market, a decade back, BlackBerry, which is very well known for its encryption technology, they are very well known even now, while they were primarily 10 decade back the leaders in the cell phone technology. One of the things that they were facing a lot of backlash, especially in India and very much in the Middle East market, was that the government in all these countries, they're actually mostly in the Middle East, they wanted to monitor their own citizens. Now, because BlackBerry was encrypting that entire data, they really wanted this encryption layer to be taken away or decrypted. BlackBerry did not agree with that, and They did not bow down to their demands, and as a result, they were out of these countries. But that's how things are. And such similar concerns right now are present with Facebook, with WhatsApp. Many people are actually gone onto the Signal application, I think, which is pretty much it regarding all these concerns. Security, cloud security involves concepts such as confidentiality, integrity, and availability. So take, for example, data at rest. You're using object storage, you get data at rest, everything is encrypted. Data in transit, probably you're using TLS or secure protocols, HTTPS. So those kind of things. And then privacy refers to protection of data and activities from unauthorized access. Resiliency is the ability of cloud services to recover from failures and errors. Resiliency is very important, right? If there is a failure, they should be able to recover from such things. Performance is the volume of demand for resources that can be handled. And governance, which is very, very important. Governance ensures effective oversight of cloud usage. Maintenance in cloud refers to activities such as installing patches, upgrading systems, etc., which cloud leads to some downtime. Now, sometimes what happens is if you use a particular service, they may specify a downtime period for it, which is done by the cloud provider itself. So you also got to be very careful, got to take into account. Like for example, Azure Synapse database or data warehouse, every 2 weeks there is a specific downtime window, especially from Tuesday, for 2 or 3 hours, there is some downtime window. So one needs to take those things also into account. Versioning is done to keep older versions of data available in the cloud to determine the stream of changes that lead the data in current set. Service levels determine the value of metrics that a cloud service needs to provide, such as availability, performance, etc. And then SLA, which is very crucial. It's an agreement or bond for performance negotiated between cloud service provider and the client. One of the metrics in the SLA is your availability component. Another one is your MTBF, mean time between failures. Because of IBM's lack of, they were not able to fulfill their SLA commitments. So, like 99.95% availability, the mean time between failures, the mean time to recover, they were quite high. So as a result, they really lost customers. Now, mind you that Oracle was actually behind IBM. Oracle really started focusing on the cloud environment way after 2016-17, which was so they were already on a delayed start. But what I feel is that they are at least ahead of IBM in this market. IBM was, they did start a decade back. So IBM always generally lags behind in all of things. Auditability, an audit verifies cloud service providers fulfilling their obligations determined in the SLA. Now, this is very important. Typically, the audits that are being performed, especially the internal audits, external audits may be well drafted, may be well done. Many times your compliance teams, they go by specific norms like ISO 27001. While there is a specific ISO standard of cloud security, they may not understand containers, microservices architecture, and they may not be very well familiar with the cloud setup, as well. So sometimes they may struggle, right? So when you talk about auditability, is there any standard around the world from which we can use as a default or a de facto template for auditing? So there is one. So what's that? Cloud Security Alliance, right? If you go into this, so it's a non-for-profit organization. It's a consortium of cloud vendors. This was started a decade back, 2010. They have something called as a star audit, right? They also have something called as a cloud control matrix, right? So if you follow these, you should be in a good space, frankly speaking. So if you go to CSA, star audit, that's where this is what so if an organization wants to get into this, you can get a star audit done from any of the star vendors. That tells you how good your posture is. The other thing could be adoption of the cloud control matrix. That's a very simple thing. These are the certain domains within the cloud control matrix. Now, along all these lines, how good is the security posture across these specific subdomains of the cloud security? It will tell you how good your standard is or how good your overall cloud security baseline is. This is an important matrix. I think this is something that should be, it's pretty much very widely used. So, and this, many organizations are using it, many organizations are not aware of it, but I think they adopted this as the ability to serve. This is one of the best practices, especially if you are focus point of cloud auditing. You could choose this as a kind of a checklist, anything under these subdomains of cloud security. What are the points you are ticking and what are the boxes you're ticking or what you aren't, that will tell you what your overall cloud security posture looks like. So this is a very important aspect of cloud security. So this can be adopted by organizations. And then we aren't, regulations is something we are dealing with inside out. If cloud providers are serving customers that are under certain regulations, then their services to meet these regulations, such as any specific government regulations in certain countries that will apply. Like for example, it could be HIPAA, could be anything else, any other regulations around the world. Now, for instance, if you're operating in a country like Australia, Australia has actually adopted the PCCI DSS standard as a default. So which means that every organization operating in the e-commerce domain or any organization operating that sort of business, they will be kicked in by the PCCI DSS rules, especially even if they end up going in the cloud, because that's the country has adopted that standard altogether. And at the moment, a lot of things are happening with the CMMC, which is based on NIST 800-171. Now, what's the beauty of it is that many countries around the world are actually adopting many variations of the NIST standards. So they are adopting, for example, the UAE government, United Arab Emirates government is adopting it. Israel is adopting a part of it. Germany is adopting, and there are some reports around Saudi Arabia are also adopting. While some of the Middle East countries, with due respect, probably they are lagging behind, with probably the exception of certain countries who are still ahead in that adoption of cloud market. But that's a norm around the world, right? This is how things are moving. We need to get started on the emerging technologies in the cloud landscape. Now, there are several new technologies emerging in the cloud, such as machine learning, blockchain, IoT, containers, and quantum computing. So let's touch base on all of these. Machine learning is a technique that allows machines to gain new abilities by learning from the already existing data sets. Machine learning is heavily used in recommendation engines and applications such as Netflix, Amazon, Flipkart, etc. Now, I'll give you a good example of machine learning here. Okay, if you go to portal.azure.com, right, and has a cloud-based or a cloud native SIM tool, right? SIM tool, which is basically used for detecting any security events and responding to those events. So Azure is probably one of the few vendors, right? One of the few cloud service providers that is providing a native in-house native SIM tool, okay, detecting security events and responding to the events. So that is to those events. So Azure has something called as Azure Sentinel. Now, Azure Sentinel is a cloud-based SIM tool, and in Azure Sentinel, you can define alerts, okay, based on certain security inputs, certain events, certain log-related events. However, in Azure Sentinel, you can also define rules based on Microsoft's machine learning algorithms. So it can do the things automatically, algorithms. So it runs behind the scenes and it can do the job for you, right? So you can define rules based on machine learning and AI. In fact, you are not defining any criteria there. You simply say rules can be defined using this. The only input that is needed for the machine learning algorithms to predict any security events or is that they need data, and data you can get by getting all your infrastructure logs in a centralized repository in Azure. You can get that to the Azure Data Lake and it can do the job for you. So it can read all the logs and check out if any such information. It can check traces for a DOS attack, denial service attack, all those kind of things. So that's an example of your machine learning solutions in Azure. Okay. Then blockchain. So blockchain is a data store for distributed decentralized ledger, which cannot be tampered with and provides high level of integrity. One of the most famous uses of blockchain is cryptocurrencies such as Bitcoin, and blockchain solutions can be built on AWS and Azure, and similar to that, IoT also. So similar to blockchain, IoT is a technique for connecting non-traditional devices in a network data collection, analysis, monitoring, and control of these devices. IoT is used by smart devices such as Amazon Echo, Google Home, smart fridges, etc. So all these emerging technologies like cryptocurrency, IoT, you can build solutions on them or on the cloud. Then comes your containers, right? Now, containers is a light way. So we are talking about the microservice architecture. We're talking about the Docker environments. We're talking about the containers that are used to manage those Docker setup environments, right? So containers like Kubernetes. So container is a light way to package up entire application to make it portable across different hardware platforms. Containers are very popular in applications such as Netflix. In Azure, you can set that up using AKS, which is nothing but the Azure Kubernetes service. So if you want to set this up, that's how you can set this up. You can check out for the service and you can set this up. And finally, quantum computing. Quantum computing is an emerging technology that allows substituting traditional bits with quantum bits for faster processing. Currently, quantum computing is being used for research purposes only. Now, I will give you an example, not from the cloud service provider for quantum computing, but if you want to take a look into this, one good example would be Checkpoint. Checkpoint is a well-known cybersecurity company, and if you look into their solution, it's actually pretty good, right? So Checkpoint's quantum computing is a platform worth checking, right? So it's definitely worth checking on this part. You should definitely check this out. This is widely also used in Checkpoint's Cloud Guard, which is a virtual firewall in the cloud. So definitely you should check this out. That serves as a good example there. So we are talking about all these emerging technologies. Now you see, there are two areas specifically that need some attention, and this is from a cloud governance point of view. I went to the Cloud Security Alliance website and showed you something called as Cloud Control Matrix or the STAR audit, right? CCM, which stands for Cloud Control Matrix, and the STAR audit. This is nothing but the Cloud Security Alliance methodology. Now, the point is, when you are using solutions like you're building IoT solutions on cloud, blockchain solutions on cloud, tomorrow you may be building 5G solutions like a company like Huawei, they've had some setbacks, but they are taken a big lead with 5G and, other related technologies, and they can leverage the same thing on the cloud. So now the point is, how do I make sure that I have a good security posture on the cloud? Because see, cloud is not just about IaaS platform and a PaaS platform. It can also be the SaaS platform. So what do I have to make sure that I have adequate security on my cloud? For instance, if I observe that my CPU utilization reaches CPU and my memory utilization reaches, let's say if I'm getting alerts, it reaches 95% utilization. Now, after that, your systems will not be able to perform. So you have two options. You can either scale up, which is vertical scaling, the thing that covered yesterday, or you can scale out, which is horizontal scaling. So let's assume you do horizontal scaling. So if you have a web server which is reaching its full capacity, you can set up auto scaling properties that, based on the alert, that 95% trigger alert, it can start spinning out new web servers of a similar configuration. Now the catch is that the existing web server has been defined with some access policies. So the key question is, you are rolling out new, as a part of your auto scaling request, you're rolling out new web servers to meet the user demand. But do we have adequate policies set up on those new servers that are just getting spinned out? The answer would be no. So your initial server, which has reached its threshold, 95% or 100% of its utilization. So the moment it reaches 95% above, you trigger your auto scaling sets, policy starts triggering, and you launch another web server somewhere in the same region or in another region to meet the demand. Now, does it have the same security posture as your existing web server, which reached its full capacity? The most likely answer would be no. So what about the security for such things? What about the security for your images, for your secrets, all those kind of things, right? So those kind of things are important, right? So what is the security posture from a compliance perspective? So for example, if you are a client running in Singapore, right? If you're running on cloud, if most of the organizations have to comply with mass, regulatory framework, which is a framework in Singapore. So how do I make sure that my cloud posture is compliant with that? There are many tools available, such as Horangi is one of them, which is a Singapore-based company. It will make sure that if you deploy that tool, it's a cloud-based tool. It provides you visibility how, with regards to how your cloud objects are stored. It gives you an assessment. It does a security assessment and provides you with a report that tells you the overall score of the resources in the cloud and what you need to do to maintain compliance with the regulatory standards or frameworks in that part of the world. So what we're talking about is CSPM, Cloud Security Posture Management. So sometimes you may have some misconfigurations, some bad settings. So you need something to figure those bad settings out and provide you with that kind of visibility. At one end you have Cloud Security Posture Management. At other end you have SaaS Security Posture Management. So these are new areas, right? These are the areas that generally tend to be ignored. And it doesn't end here. It's not just about the cloud security posture management. Assume that I'm building up some sort of block cryptocurrency solution using cloud. So how can I audit? What do I do to audit my setup? So I can go for a cloud audit. At the same time, I can go for a cryptocurrency audit, right? Now in cryptocurrency, you may have heard across standards like ISO 27001. So if you go on the site, Crypto Consortium, you will find that they have a standard for cryptocurrency. It's a security standard similar to ISO. It addresses a different area, which is the cryptocurrency security standard. So you have a security standard available for cryptocurrency also. Similarly, there are standards available for IoT platform, for 5G also. So that's the whole idea. So you not only can you do a cloud audit based on the star audit, but you can also do something like this. So that's the reason why it becomes important to look at all aspects. And you can get involved as a blockchain auditor. You can, if you become familiar with cryptocurrency standard audit, which is one of the only few certifications from cryptocurrency perspective. So this is what it will help you. Cloud computing security concepts. Now there are 6 security concepts relevant to cloud computing. These are cryptography, access control, data and media sanitization, network security, virtualization security, and common threads. Let's cover them one by one. Now, cryptography. In cloud computing, cryptography plays a major role in data security. Some of the important aspects to consider are encryption, key management, data in motion, and data at rest. When we talk about database encryption, every organization's data, their business data resides in databases. So if you can break that up, you can get something, either breaking that up and just seeing, and if you have built something up with that, I think that's really good. We're talking about not just about cryptography, we're talking about the entire landscape. Where it is helpful, what are the use cases? Think about cryptography or any area in security from a perspective of what are the benefits or use cases it is providing? Are there any relevant risks of using the technology and any downsides? And does it support from a governance perspective? Is it subjective to audit? So for instance, if you are using first your S3 buckets or your object storage, that uses encryption. Amazon S3 will use encryption. Your Microsoft Azure blob storage or Azure Data Lake, that's the new term for it. Azure Data Lake generation 2 now. It was a little earlier generation 1. So that uses encryption. When we say these are examples of data at rest encryption, because here you dump all the data in one place. Object storage is nothing but long-term storage, right? So it is not used for faster data retrieval. Maybe you can store your historical data or archival data there, right? If you want anything to be used for instance, if you want something to be processed for OLTP, right? Then you need to attach block storage. So block storage to any of your IS servers or something, and they will provide you with this kind of a feature. Even if you're using PaaS service, internally any of the PaaS databases, internally they are connected to block storage, right? Now, the point here is these are the use cases. It can secure your information, right? Especially for data at rest. And we'll talk about data in motion also. So it can secure your data using 250 AES or any other encryption methods. So if it uses AES, Advanced Encryption Standard, it could be 256 bits or more. That could be the length of the key. The data at motion basically talks about any data. So for instance, let's say you are using BitLocker encryption, in one of your web servers, right? And you're not using the Azure web application, but let's say you have set up a VM and then just installed the IIS web server there. It's the classical on-prem kind of thing that you usually do on the IIS platform, right? Because you want more fine-grained control, you want to be able to tune the settings according to your requirements, so you have gone for that. Now that's the scenario that we're talking about. Now the drive where you're hosting your Windows server, right, on which your IIS server is hosted, the drive is encrypted by BitLocker. So that's an example of block storage. These are either S3 buckets, something like a Windows server virtual machine that is connected to a data disk, which is a data disk and operating system disk, which is nothing but protected by BitLocker encryption. They are examples of data. Now you make some queries to the web server. You made a specific query. The web server is sending you some data. Now there is some latency between you and the web server. So whatever data it is sending you, that is data in transit or data in motion. So data that is traversing from source to destination or from destination to the source. So it's the data that is traveling. It's not static. And this data needs to be protected. So you can use SSL, you can use HTTPS, and basically you need to use a secure passage to provide that layer of encryption, application level encryption for the data that is traversing over the internet. That is data in motion. Now, cryptography is a science. So cryptography consists of encryption and decryption. Encryption is the process of converting human readable data into a format that does not make sense to the end user. So it basically converts human readable data into ciphertext, which is a format that is not understood by humans. And decryption is the process of decrypting the data which is not understood by humans to a format which is understood by humans, or to back to its original form, right? So the cryptography involves encryption and decryption. Now, how is key management related to that? So now let's say you have set up a resource group in Azure. Resource group in Azure is nothing but a collection of all the resources that you have. It's a logical kind of entity. So it's a placeholder under which you have placed all your resources, right? So for instance, you may have set up a database server, a web server, you may have set up a container, and lots of different kind of things you may have set up, right? Now, this resource group is the placeholder under which you have, and all of these, whether your database server or a web server, they are all accessible by, you encrypted them. So they're accessible by some keys. Now the problem is, where do you store the keys? And if you store the keys with yourself, there is a potential chance that you may lose the keys. So key management is centralized location where you can keep all the keys of your resources under one centralized location. And the cloud service providers provides you that. So it's the management and storage of encryption keys, right? So that's what it does. So we have talked about encryption, key management, data in motion, data at rest, and data at rest. So we understand that it's one of the benefits is that you can encrypt your data, and by doing that, no third party will be able to decrypt your message, if they're trying to sniff your packets or something. So it provides an extra layer of protection. Now, before we discuss the second advantage, let's talk about one of the disadvantages in this architecture. So let's say I'm doing encryption now, because let's say I've got 10 resources and I have set up the encryption keys for all of them, and all the encryption keys are different. Now, if I maintain all these keys in an Excel file, I can lose the file, right? And then I lose access to my own data. So I need to make sure that there is a safe location where I can keep it. So that's where you have Azure Key Vault, you have Alibaba KMS, Key Management Service, where you can store your keys. It's a centralized location where you can securely store your keys and access, and you can use them when needed to access a particular resource. One of the disadvantages is that now not only your application, but also your application, your cloud resources, your data, and the encryption keys are also under the control of the cloud service provider. That's the catch. Now, while as a good practice, the cloud service provider, you are paying them, they have nothing to do with your data, right? But isn't that a risk factor? There is a perennial risk, some degree of risk is involved, because if there is disgruntled employee at cloud service providers end, they may come just in an ad hoc manner, just try to take your keys and decrypt your own data and just damage your reputation. So while that guy may end up getting fired.
Just a quick info, guys. Intellipaat provides CCSP certification training, mentored by industry experts, the course link of which is given in the description below. Now, let's continue with the session.
Your reputation is also taken for a toss, because here you are at the mercy of the cloud service provider, because you are keeping all the keys in one place. So definitely the cloud service provider will have access to the keys. Now, as a good practice, they will not do this kind of things. That's for sure. But whenever a leak happens, whenever any companies, there is a data leak or there's a cybersecurity incident that happens in any company, it's not the company's intent to leak that or to get bad reputation. Somebody does it, right? Either an external guy or an internal guy. SolarWinds, which is such a well-known organization, very well known for its monitoring software, very well known for its cybersecurity also. Sometime around this time last year or at the start of this year, they faced a massive cybersecurity breach.
Just a quick info, guys. Test your knowledge of cloud security by answering this question. Which data may not be suitable for public clouds? A. Legacy application data. B. Mission critical workloads. C. Sensitive data. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Or their systems, one of their systems was exploited, one of the vulnerabilities was exploited. It may be very advanced, but the point is they were targeted, right? So while that was not someone's fault, it was somebody's fault because nobody paid. There were some areas that were found wanting, and that as a result, external hackers were able to exploit some vulnerability. So there is a potential risk, especially with key management, because you are storing all the risks here. Sorry, you're not the risk, sorry. You're storing all the keys here. So from a risk perspective, there is some degree of risk. Now you have no choice to accept that. But the point is, if you do not want your keys to be under control of somebody, you can use external providers. So for instance, Google has partnered with external providers for key management and storage. So this problem is taken away. Somebody else is doing that job for you. Now, one of the vendors, well-known vendors in this industry is Fortanix. It is a hardware security module. So how does it work? How does it integrate? So if you check out Fortanix partnership with Google or AWS, you will be external key management, right? So you can check this out. So Google platform collaborates with this, right? What all things can you do? You can generate and store keys externally outside the cloud. So you can generate the keys also outside the cloud. Now that's a different thing. Customer control over encryption in cloud with customer owned keys. Now you don't have to manage the keys either, but you have control over generation of the keys and keeping them outside the cloud. So you have a controlled key access, central audit, and policy management. So these are the things that you can do with hardware security modules and external ones. And why did Google partner with somebody like this? Google can generate the keys for you, but what was the need for it? So you can say they newly announced Google External Key Management Service, because there is a potential risk within the cloud. The cloud provider has too much control over your applications and your data. So you want to have some level of control, isn't it? That's how you manage control over that, right? So this is one of the demerits, because the cloud has too much control. They can decrypt your own data, right? So in this case, you should go for external key management service like Fortanix, and Google partnered rightly with them. The next benefit is that there is something called as crypto shedding. Let's say you have decided to move from, let's say you find AWS, from a price point, you find it very costly. right? And now you want to move to somebody who is very cost effective. So let's say you decided to move from AWS to Alibaba Cloud, right? All cloud managed services have high SLS2, that's true. So let's say you decided to move from AWS to Alibaba because from a pricing point of view, it'll be easier. Now, there's no such problem here, but your organization worries that you are storing your data on this guy's infrastructure, right? So even if you delete the data with some forensics tools, they may be able to, and if you move away from them, they may be able to recover your data. The cloud service provider can still recover the data using some forensic tools. So that's a concern, probably for customers, such customers who move away, right? These guys can cause some damage. And to be honest, vendors like AWS, Azure, big organizations for sure, but malpractices can happen in any organization of any sort. You can't just rely on the fact that they are huge and everything is ethical there. You can't just go by that. They would have certain policies, but at the end of the day, it's a private organization, and you cannot just have a de facto trust in another provider, right? So while they will not do this kind of a thing for sure, but you can't just rest assured because something which is beyond your control can be misused, right? And you will not even come to know of that. Like for example, Microsoft, since 2017, they have a policy. They can perform pen testing on their infrastructure. If they have leased their infrastructure to you as a customer, you're paying for it, then you are the owner till the time you are with them, right? You are the one, because you're paying service for it. But what they have said is they can pen test even your data as well. They don't need your permission. In fact, they will just go ahead. They have a very generic comment which is mentioned on the website. They can go ahead and pen test their infrastructure without your permission, even if you're hosting your own data there. So they don't need prior approval for this. So what do we do in such cases? Especially if you are migrating from one cloud provider to another, you can use something called as crypto shredding, right? Now, crypto shredding is interesting. You encrypt your data and you delete your encryption keys. Okay, encrypt your data. You're not deleting your data, but you're deleting your encryption keys. If you delete your encryption keys, they also would need to decrypt your data, isn't it? That's crypto shredding for you. Now, at least here you can just assure that they will not get access to your data because you have lost the keys. You've deliberately, you've done it deliberately, right? So intentionally you deleted your encryption keys because you decided to move to another vendor and you just want to make sure that this cloud provider cannot get access to your data. So it's as simple as that. So encryption is nothing but the process for encoding information to make it impossible to understand the encoded text. So basically conversion of original information to cipher text. This text is encoded using a key, which is then used to convert it back to original information, which is called decryption. Key management refers to managing cryptographic keys within a system that uses cryptography. So basically, key management refers to generation of keys, exchanging of keys, storing keys, using and replacing keys as needed at the user level. Now, Brian did mention this prior to the break. He raised a valid point where he said, if you're using crypto sharing and if you still delete the keys, all these things like key generation can happen. The cloud provider may even keep backups of your keys, right? So so while you may have a good sense of security, that it may give you a good impression of security, right? That the cloud service provider doesn't have any way to decrypt your data. That could turn out to be a false narrative, right? So you have options such as going towards external key provider for key generation management and all those things. So that way you're well covered, and it's outside. The decryption process remains beyond the realms of the cloud provider. And the second hand, if you still, when you adopt key management, it comes as a part of the package of what you pay for, right? And if you go with the external provider, you got to pay some price for it, right? So many customers don't do that. So if you go with the second option where you utilize the cloud service provider's platform for key management, one of the ways to look at if something wrong happens is to get covered from a non-disclosure agreement. So while it definitely may cause some damage, but at least you can get, there are penalty provisions for the cloud provider in that case. Data at motion and rest. In cloud, data that is either at rest, that is stored in a device, or in motion means that data is transmitted over the network, and both of these need to be protected and secured. Data at rest is encrypted by default. However, data being transmitted from a client to the cloud infrastructure needs to be sent over an encrypted connection using HTTPS SSL. So this is how you can set up a good security posture on cloud using the SASE framework. So this is how you will you can access these things. So we talked about all this part. Let's go on to security. Next, security control related to access, data access. Let's talk about this. Now, what is access control? Access control is a major source of security flaws in cloud computing. Access control refers to granting and revoking a user authorization over some data or service. In cloud computing, access control can be managed in several ways. However, in real world practice, organizations tend to manage access control locally due to its importance to organization information security. This is done so that the organization has full control over granting and revoking access to cloud computing services and data. Absolutely correct. Let's talk about data and media sanitization. This is a very important area. We touched base upon this earlier. Data and media sanitization refers to dealing with encrypted data when being erased, changed, or overwritten. When dealing with secure and encrypted data, there are several concerns we need to be aware of. For example, we may have to delete or overwrite a small piece of data that is encrypted using a key. If the key is only used for that data, then we should remove the data and then remove the key as well. For security purposes, all cryptographically secure data should be deleted or overwritten in such a way that it cannot be recovered successfully. And that brings to the point which Brian mentioned, that you may overwrite the data multiple times, but are you absolutely sure that the provider may have a backup of the data in some other location? In some other, you will not have any idea. So frankly speaking, the moment we decide to host our application on the cloud, we are pretty much at the mercy of the cloud service provider. Network security. Network security allows us to impose restrictions on incoming and outgoing traffic in a virtual or real environment. Many cloud services provide several tools which we can use to better protect our virtual networks in the cloud. For example, we can use network security groups in Azure for applying specific security rules on a group of resources. Firewall should be properly used to prevent unauthorized access to our networks. Set security rules to only grant networking access to resources that need them. So the whole idea here is, from a network security perspective, follow the concept of least privilege. Give only that level of access that is desired, that is needed to perform, for somebody to perform their job role. Now, I'll give one example of network security. Now, this is debatable. Okay, so be it any cloud provider. Okay, I'll just restrict myself to Azure for a moment. Right, doesn't matter who the provider is. It could be AWS. Now, you have a subnet, right, in Azure. So what are the default networking rules defined? And this also is pretty much with every other platform. So as a default rule, any incoming traffic to your cloud resources is blocked. That's by default. But outgoing traffic is allowed by default. Now, this makes sense because you want to define certain ports and certain things to be, you define something, some rules, and then you explicitly enable those ports, so you want connectivity from the internet to your internal network or from specific services or ports. But there's a default trust factor for outgoing traffic, which doesn't make sense. So for example, if you were using, okay, if anybody was using cloud virtual machine, right, to send company data to an outside entity, by default, this rule means that they will not be blocked. They are allowed. That's a no-brainer. It doesn't make sense, right? See, internal, we understand that there is external perception of external threat, but how you get an on-premise firewall where everything is nothing is allowed? You have to explicitly configure rules. But here in cloud setup, any outgoing traffic from a trusted cloud resource is always allowed. Why is that? And that's a de facto rule. Now, this also should be not allowed in the first place. And then this rule should be overridden on specific port for a particular cloud resource to send outgoing traffic to the internet, right? So this rule is by default allowed. That is, if somebody quickly deploys their services, then this is presenting a risk factor. Virtualization security. Virtualization comes with its own set of security concerns. As virtualization deals with hypervisors and host operating systems as well, we need to be cognizant of several flaws in their security. A virtual machine attached to a hypervisor is affected when the host hypervisor is also compromised. Even when you are using containers, you have to be cognizant of these security concerns. Common virtualization security threats include DOS attacks, host traffic interception, VM jumping. They are all examples of this. Now, virtualization comes with its own set of security challenges. Now, while you may not have visibility to the hypervisor, you still need to be cognizant of the fact that if somebody can manipulate at the hypervisor level, any guest operating systems that are running on top of it, they are all compromised. So hypervisor attack, one layer where it has the potential to compromise all the guest operating systems that are running on top of that. If there is a hypervisor attack, this is where your cloud service provider will be under serious repercussions on the cloud service provider's security posture. Let's talk about some of the common threats. Cloud Security Alliance has defined the 9 of the most common security threats in cloud computing. These are data breach, data loss, insecure interfaces, account and service hijacking, denial of service attack and distributed denial of service attacks, malicious insiders, abuse of cloud-based services, shared technology vulnerabilities, and insufficient due diligence. Data breaches can cost a lot of this thing. That's the reason why having a good DLP solution is going to be very effective. Have a good data loss prevention solution, like a force point kind of a thing, will always help you. So let's talk about all of them one by one. So in simple terms, data breach refers to a situation where the data is accessed by someone who is not supposed to have access to it. Your organization should have a data breach policy, response policy, how you respond to data breaches. Is that breach caused by you or by the provider? That will also be interesting, right? So probably it may be caused by the provider. It may be because they are eventually the backend data they are storing for you. It is also possible that this is done by some insider, somebody from the cloud consumer side, customer side. Data loss is also a threat. Your users may end up losing their personal and valuable data on cloud computing platforms because of various reasons, and if no backup is present, then the data is normally lost. Now, if you delete, one has to be very careful when you delete cloud resources. One should be familiar with, prior to deleting, if somebody is new to the cloud, prior to deleting resources, they should do a thorough check with their counterparts, with somebody who has experience, right? Because when you delete something, and if let's say you don't have the backup of that, your data is gone. So you got to be careful on that part. Insecure interfaces, we may expose several APIs to allow integration with customers on on-premise systems, and therefore we need to have proper authentication and authorization mechanism in place. API security is paramount. We need to make sure that integration is secure and APIs are not leaked. So we can deploy whatever security controls are required for API protection, that should be deployed. And also, because API connections are also used in automated platforms. For example, if you're using certain monitoring tools, your APIs, it may be getting access via certain API. If you have set up something like RabbitMQ, like a messaging service, it will be using the API connection. So you got to make sure, you got to be aware these API connections are being utilized, right? And you got to make sure that there are appropriate security controls where all these connections are being made. Account hijacking. So here attackers use methods such as phishing, fraud, and exploitation to gain access to user credentials, and therefore the accounts can be compromised. One has to be careful if they're using their corporate systems, laptops for accessing cloud resources. Externally also, fall into a phishing trap or on a phishing trap, your systems can be compromised and somebody else can also get access to your resources. Then DOS attacks and distributed denial of service attacks. These attacks prevent legitimate users of a cloud service from gaining access to their data and applications because of a system slowdown caused by a large volume of requests coming to these services. Now, DOS attacks we are well familiar with. Then we have malicious insiders, so somebody who is within the organization and has some malicious intent. A malicious insider is a current or a former employee who has or had authorized access to an organization's network, system, or data and intentionally misuses that access to negatively affect its security. Malicious insiders can also cause these issues. Abuse of cloud-based services. A malicious user might end up using cloud services to do some damage to another organization's network, such as distributed access attack, brute force attack to guess someone's credentials. Now it's interesting. You are leveraging, like you are sitting in one location, right? Now think if you are the hacker. Let's say you are accessing the Ireland data center and you are sitting somewhere in a place like Turkey. You're accessing the cloud data center, which is there from the portal. You connect to a virtual machine, which is also in, which is also there in Azure's Ireland data center. And from there, you try to compromise the system, which is somewhere there in Netherlands. A company's data, you're trying to pen test someone or trying to, compromise someone's system. So that's abuse of cloud-based services to target somebody else. Now the traces, what are the traces of what IP address traces with, if any, on the victim side? They will see the cloud service provider traces, not your traces. They will not be able to. It will be hard for them to reach out to you. While it's not certainly not impossible, but it will be a bit hard for them to reach out to you. Share technology vulnerabilities. Since cloud providers use virtualization, if any host system becomes compromised, then multiple virtual systems become compromised as well. Best example, if there is a hypervisor attack, all the guest operating systems running on top of it are all compromised. Insufficient due diligence. If an organization uses cloud computing services and they do not take care of security on their end using techniques such as encryption, security monitoring, etc., then an attacker could exploit these loopholes. Most of the times, it is out of all the 9 problems, it is insufficient due diligence. For example, bad configuration. For example, not focusing on the prior to deployment or prior to coming on the cloud, the NDA, non-disclosure agreement with the cloud provider, the SLA with the cloud provider, right? All those also, just because you come on the cloud provider, while some customers still think about deploying a web application firewall in front of a web server, there are some customers who just come on the cloud feeling that, okay, this is not our setup. Microsoft is managing security for us. We pay them on a monthly basis, let's say $2,000, but they are managing it for us, so we don't have to worry about deploying antivirus or anti-malware solution. And the next moment, a month later, you see that your system is compromised, and then you end up blaming the vendor, cloud service provider. It was your prerogative. You should have done due diligence on what are the cloud providers' responsibilities and what are your responsibilities. So many times it is 8 times out of 10, it is insufficient due diligence, which is the single largest threat amongst all the threats. Now, secure cloud computing design principles. Now, these are the 5 key principles relevant to secure cloud computing. These are cloud security data lifecycle, disaster recovery and business continuity, cost benefit analysis, functional security requirements, and cloud categories security considerations. Let's touch base upon all of them one by one. Now, what is the cloud security data lifecycle? It's very easy, actually. You have 6 stages. You have the create stage, store stage, use stage, share, archive, and destroy. And I'll quickly touch upon it. Now, let's say you are a company that is involved in some sort of forecasting. Let's say you are your organization is building revenue management software for hotel industry, right? And you are deploying your services on the cloud. Now, given this, so for instance, we are well aware that 3 weeks from now, right, during the time of Christmas, you can expect a large occupancy in hotels. So most of the hotels will be, filled up, and that pattern will continue for another 1 week till the New Year's Eve, right? So probably somewhere from a day prior to the Christmas till 2nd or 3rd of January, many people will actually go on leave, right? That's the time when hotels are occupied. It's a well-known fact. So what will happen is the pricing on those days will be very high as compared to. So if you look at the hotel's rooms price on 20th of December, and if you compare that to 25th December or on 1st of January, you will know that there's a huge difference. On 20th December, the price will be a lot lower than 25th December. So this company is building revenue management forecasting. It gives predictions to hotels, so that they can up their pricing accordingly based on previous year's data, right? So the first thing what they need is data. So probably this company, which is a new startup, it would have crawled or got some data from Expedia, may have done some web crawling and would have got some data. So that data is now raw data that you get, right? Now this raw data is not of much use because it is not doing any business intelligence. Now you create that or you get it from someplace, right? And then you store it, you dump it somewhere, let's say in your object storage. Create and store. Now what you do is you apply ETL, extract, transform, load. You get the raw data, you store it, then you transform that data. So convert the raw data into processed data, and that is generally done through data extraction, applying some business logic. You transform the data. Once you have transformed the data, the raw data it's now converted into processed data. Now this processed data can be used in business reports. Now you can use it for forecasting and something. So now you can use business intelligence tools like Tableau and so others to give some numbers or present some reports. So now this is used for you, right? And now because it is usable, you can share the data with your customers. So what's the time of use phase? The use phase comes after transforming the raw data into processed data. So it's probably used in reports. Then you share the data with the other users, right? You share your reports with the users. Now, once the transformation has been done, once the data has been consumed, it's been used in business reports. Now this data is not current. It's no longer of much use. So now you can archive this data. You archive the data, you may still require that data at a later stage for historical retention requirements, for historical reporting. And once you have crossed the stage of requiring this data for business requirements, you can destroy the data. That covers all the 6 phases: data creation, data storage, data being used, data being shared, data being archived, and data being destroyed. That's the 6 phases. That is exactly what your cloud secure data lifecycle is all about. So first stage, create stage, get the raw data on it, create the raw data or get it on the cloud platform. Then store it. In this stage, data is at rest and stored on a cloud computing platform. Now you can decide if you want to store this data on an object storage or you want to store this data on a block volume. That's all up to you. Mostly it will be stored on a block volume. It will not be dumped on the cloud. This thing, because retrieving the data from object storage, and so retrieving and addressing that, right, that takes a bit of time. So there are latency issues. Object storage is not designed for fast performance, so it's not designed for real time, for OLTP setup. So that's the reason why you would be using block volume. So once you have used it, in this stage, data that was stored earlier is being used by a user inside a cloud computing service. Yes. And then share. So here many times data is shared among different people with different levels of authorization. So as I said, as an example, I gave this where BI reports are being generated and they're shared with business users. And then you archive the data. This data becomes stale. It's no longer relevant for current business needs. It is still relevant for historical requirement, but it is no longer. So what you do is now you push this data from your block storage to object storage like S3 buckets or Azure Data Lake. And finally, once it has crossed that requirements, you can then go ahead and destroy the data. Right? So let's move on to disaster recovery and business continuity planning. In cloud computing, the 2 major design concerns with respect to data are DR and business continuity, disaster recovery and business continuity. Now, before I go further, we need to distinguish between DR and business continuity. Now, I will say that DR is a subset of business continuity. BCP, business continuity, is larger behemoth, right? It's the giant. Now, what exactly is DR and business continuity? Business continuity talks about any interruption in business services. So there is some interruption. That interruption does not necessarily mean it's an outage. Disaster recovery means it's an outage. That's the simple thing, right? Now, because outage itself is an interruption, but it could be for a longer time. And there could be that because of some internet latency issues for a minute or so, your web server was not accessible. So that's an interruption, but it's not a disaster. So we need to be clear with the definition between DR and business continuity. So disaster recovery, it's the plan of action that needs to be implemented when disaster strikes, such as loss of data, data integrity violation, etc. And business continuity, it's the objective of disaster recovery systems is to ensure business continuity and prevent organizations from suffering substantial damage in the form of losses to revenue, reputation, market share, etc. In short, business continuity is interruption in services. Disaster recovery seems clearly means outage. For business continuity, there are two major success factors. These are understanding, so what are your responsibilities and what are cloud service providers' responsibilities. Clearly state and prove what the cloud service level agreements components are covered.
Just a quick info, guys. Test your knowledge of cloud security by answering this question. Which data may not be suitable for public clouds? A. Legacy application data. B. Mission critical workloads. C. Sensitive data. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
And the depth of the coverage. Now, for DR requirements, you have to be very, very clear. You have to be absolutely clear with what you are going for. The cloud providers can, their marketing guys can fool you, So you got to be absolutely be sure what you're going. Simple thing. Are you deploying your applications in the same region or in a different region? Are you going for local backups or are you going for geo redundant backups? Are you doing point in time recovery? What's the lag between your production and standby systems? Like if you have a production product PostgreSQL database and if you have a standby database, let's say you have the production PostgreSQL database running in your Ireland data center and the standby is running in the Netherlands data center. What is the lag between them? Are you keeping your standby services up and running all the time? Or are you restoring from backups? What is your planning? So all those things. Have you tested your backups? Is the cloud service provider now, because it's all in the form of a single click. What about the reliability of backups? Whatever backups that you have taken, those backups are with the help of a single click on your browser, you are doing the backups, right? So all those are considerations that need to be talked about when you sign your NDA and when you sign your SLA. So you see, we are going back to square one, which is before coming on the cloud, make a note of all these things. Talk and discuss with your cloud service provider all these things. Backups can fail. All these things can happen. So if this was an on-prem system, what would we be doing in general? We'll be taking the backups on a weekly basis or depending on a fortnightly basis. We'll be testing our backups. That's what you would have a COP system, which is your continuity on business systems, where you will simply restore your backups. You will test your backups. While you may test your backups in the cloud, you're not going to set up every now and then you're not going to set up, if your backups are working, what if they become corrupted? That's how do you validate that? In Oracle, you have a utility called as RMAN, Recovery Manager. There you can test the backups, you can validate the backups, you can do all these things. Security concepts, cost benefit analysis. CBA plays a major role in deciding security concepts and the solutions. Cost benefit analysis allows us to compare different platforms on the basis of expenditure needed for a service with the value provided by a service. Now you see why we are talking about CBA, because unlike software development, when you talk about security, here you require investments. There is no direct monetary benefit as a result of implementing security controls, right? So whatever you deploy, it has to be seen from the context of cost benefit analysis and other techniques. There is no direct monetary benefit of deploying security controls. Its cost has often been called the key driver for whether an organization will adopt cloud computing in some capacity. Different cloud computing solutions provide different services at different prices, and they need to be thoroughly examined to choose the best option. Functional security requirements. Function security requirements in the cloud, these are portability, interoperability, vendor lock-in. Yeah, many times if you work with Amazon Redshift or DynamoDB, that they can be a vendor lock-in feature. Portability, easily and securely moving data from one service to another service. That is portability. Interoperability, multiple services being able to access and manipulate data securely. And vendor lock-in, moving encrypted data from one cloud service provider to another cloud service provider securely. This can be a hazard, and with databases, with especially with databases which are like, for example, if you're working with RDS for PostgreSQL, right? That will still work because in PostgreSQL you can take logical backups. So if you have a larger data set, you might still be able to take a schema level backup and or make a table level backup. You will be able to do a schema level backup easily and move on to another platform. But if it is DynamoDB or if some vendor specific thing, then it will be hard for you to do that. Design principles, cloud security considerations. Depending on the service model, we can have different security considerations such as software as a service, platform as a service, and infrastructure as a service. Okay. Software as a service, here the data is being encrypted when it is transmitted over the network. Is the application preventing against common attacks such as SQL injection, cross-site scripting attacks. XSS stands for cross-site scripting attacks. Are proper measures in place in case of application security being compromised? So all those are the questions that we need to answer. Platform as a service. Interestingly, this is very interesting. Are we using the latest version of platform services? Are the softwares being used in deployment up to date with latest security patches? Is the deployment process using the latest security standard? We come to infrastructure as a service. Here we have to ask questions related to, are all the networks properly configured? Are all proper backups and replication strategies in place? Do host machines have the latest operating system and security patches installed on them? All of these are questions. Evaluating cloud service providers, and then now there are three major ways of evaluating cloud service providers. You got to look at if they are certified with any specific standards, security standards. ISO 27017 is related to cloud security, PCCI standards, and there are some government security standards, as well. As an organization, you want to see if with how many security certifications this vendor has. That gives you a good posture of their security apparatus. ISO 27017, it provides standard guidance for implementing security concepts in the cloud. Many cloud computing providers offer services that comply with these standards. So if we see this, it will tell you how this vendor has this level of security posture. So it's only a certification attestation by a third party. So that just tells you that at least they have some decent level of controls. But still, don't just go by the nomenclature, right? Just don't stick by that. You'll have to also consider other specifics as well. PCCI DSS, it stands for Payment Card Industry Data Security Standard. By the way, in countries like Australia, they completely mandated the use of PCCI DSS as a standard. So whether you go on cloud or not, the whole idea is that you will still be bound by the rules of PCCI DSS. So if any company is compliant with that, good enough. And then there are different government agencies, right? That are subject to different security standards which need to be adhered by cloud computing providers. You can talk about the NIST, cybersecurity, any of the best practices. You could use the common criteria certification for hardware and software products. Standards, you can use the Federal Information Processing Standards. Obviously, these are US-based standards to certify cryptographic security in government services, all those kind of things, right? What is our understanding? What all things can we do? We can set up a infrastructure as a service platform. We can use the platform as a service solution, and then we can go for software as a service. Right? So these are some of the things that we are very familiar with in this. Right? Now, when we talk about infrastructure as a service, we can deploy virtual machines, and on top of that, you can probably go and deploy any application or specific tools. Right? When it comes to platform as a service, I mean, this is nothing but inherent cloud services that we're using. So for example, let's take Amazon RDS or Amazon Redshift, which is a data warehouse. And SaaS, we are well familiar with tools like Office 365. We are familiar with G Suite, Salesforce. These are some of the tools that we are well familiar with, right? Now, this is where we end up going. Then our understanding is, then we talk about the containers or the microservice architecture, right? That's the another piece of it, microservice architecture. Okay. We talk here about things like what Kubernetes, Docker containers, right? And then obviously, I'm going to be attaching this to obviously with the configuration management tools like Ansible, Puppet, and Jenkins. So bottom line is the entire DevOps, you get services and so on, right? So this is the entire modus operandi, when it goes towards the microservices architecture. Another thing is this the only piece of it? Can we go, is there a different dimension to the cloud beyond this? I mean, this is in general what constitutes the entire cloud. But is this all? Has cloud got nothing further to offer? I mean, these are the questions that we need to get around and see if we can get responses on that. Now, what are the existing differentiators? Okay. Now, for instance, if you want to do threat hunting, okay, one of the amongst all the vendors, the only native tool, this feature is not available in Oracle Cloud, not in Alibaba Cloud, not with Google, not with Amazon. It's only available with Azure. Now, when I say cloud native threat hunting solution, which means the vendor specific itself. So now the vendor like Microsoft offers Sentinel, Azure Sentinel. Now this is roughly a product that's almost 2 years old. And this is a SIM tool. It's a security integrated event management tool. Okay. So basically it can aggregate all your logs. You can centralize all your logs in one place. And this tool can read all your logs and convert that information into some sort of security analytics. So it gives you a dashboard. It looks out all the logs, finds out based on the rules that you define, and it can have its own defined rules because Microsoft leverages its own machine learning and AI algorithms to find something suspicious, and they can report such things. So that's the role of the Azure Center. And this is somewhat different from the other thing because the other vendors don't have an in-house offering, right? That's the whole point. Now, if I talk about, and that's where you will start looking towards third-party solutions. That's where you will start looking towards third-party solutions. So this is the initial differentiator. The other part is, now when it comes to SaaS tools, are we just focused on Office 365, G Suite, Salesforce? Is that it? Is there nothing else that could be offered? So there are multiple solutions available, and we'll touch base upon each one of them. And that's the whole idea. Now, I'll talk about something called as CSPM, okay, which is nothing but Cloud Security Posture Management. And then we have something called as SSPM, which talks about SaaS Security Posture Management. Now, if you look at the list of controls, it's exhaustive. Whatever we're talking about here, it just doesn't end here. That's not the word, right? There's a lot beyond it. So for instance, if you look at this cloud control matrix, and now for instance, let's take an example. Now, let's say you have some financial firm like Bloomberg, right? So if tomorrow Bloomberg comes with a SaaS tool, or Franklin Templeton comes with a SaaS tool for wealth management, which is one of the important verticals for financial services. So if that happens, that tool will be successful because there's a growing demand for all these kind of things. And it provides seamless connectivity, because if I can have my wealth management reports through my app, that's a lot better than just logging in physically and all those kind of things. But what about the security of this wealth management app? What about it's a SaaS tool, so how secure it would be? Those things bring a different dimension. Now, imagine if you are a SaaS provider and your customers, if you are Franklin Templeton, if you are executive, one of the employees of Franklin Templeton, your clients will, come back to you saying that, hey, what about the security of this, right? You are taking in our data. What about the security? Is there some way we can get some kind of reports that ensures that your SaaS tool is good enough from a security landscape. So the moment you talk about SaaS security, your customers will be convinced about, or if you're SOC 2 certified, it adds a lot of credibility to your organization. And it gives your customers, they can get a sense of security, because if you're SOC 2 audited and you're certified, that demonstrates your layer, that how good or how well.
Just a quick info, guys. Intellipaat provides CCSP certification training, mentored by industry experts, the course link of which is given in the description below. Now, let's continue with the session.
Your security posture is being managed, right? So SOC 2, that's a very relevant point. And this is what most of the SaaS providers end up doing. I'll give you one good example. There is a Singapore-based company called as Horangi, okay? I often deal with them. Horangi is basically a CSPM provider, Cloud Security Posture Management. First, let's see what is Cloud Security Posture Management, right? CSPM. You can see here, Cloud Security Posture Management is Cloud Security Posture Management automates cloud security management across the different dimensions of your cloud. So for infrastructure as a service, instant computing of infrastructure provision and manage over internet, and your SaaS service, right? What it does is it provides the necessary security control over all these things, especially. So if you have certain misconfigurations, it can check that out and it can help you to, it can detect that. Something that anything else will not be able to do, right? So your CSPM solutions can automatically and continuously check for misconfiguration that can lead to data breaches and data leaks. This automated detection allows organizations to make necessary changes on a continuous, ongoing basis. Now, misconfigurations can happen anytime there, because everything is human controlled. So misconfigurations can happen anytime. This can happen through your APIs. It can happen through some human errors. You leave one door for the attacker to enter, and they will definitely enter and they will damage your infrastructure. So you got to look at your posture management, mostly to do with security misconfigurations. That's where your cloud security tools like Horangi, they help not only to improve your cloud security posture management, but they also help you to meet regulatory compliance. Now, especially if you're in Singapore market, they have something called as mass compliance, right? It's a regulatory compliance within Singapore market. That tool itself, if you are completely deployed on cloud, and especially if you are a bank, then that compliance is already met there, right? With the help of tools like Horangi, you can achieve this you can achieve compliance, as well as you will not have any security misconfigurations. So that's the whole idea. And the next part is that, now just for your knowledge, Horangi as a company, okay, itself, they offer a product, right? And they themselves are SOC 2 certified, and they got it recently. Now they're offering a product called as Warden, right? And they are themselves SOC 2 compliant. So they recently got the SOC 2 certification themselves. So you can see one of the first companies in Asia to achieve SOC 2 Type 2 compliance and certification, because they are offering a tool for your compliance. They can look into things like access control, change management, risk mitigation, system operations, all these kind of things. So a lot of these things will be helpful, So cloud security posture management, it helps you to improve it gives you visibility. Now, Checkpoint offers CloudGuard. Horangi also offers certain tools, and there are many other vendors in the market who give out these kind of tools. Okay. Then your SaaS security posture management. Now, your SaaS security also needs to improve. That's another piece. Then, now, for instance, Azure offers a web application firewall. Now, does it have all the features? Azure also offers a network firewall. Is it something that is comparable to Palo Alto, those kind of things? I think these are the questions that you need to think about and answer. You got to see if the native cloud vendor is giving all those features. Now, moving to the cloud itself comes with some risk, and this is what organizations take. But these are some of the things that we have to be very clear about. What are the responsibilities between the cloud service provider Are they willing to sign NDA? Are they willing to get a customized SLA and get down to your requirements? Are they going to fulfill that, or are they going to back down from that? Now, legal risk and compliance, let's talk about it. Now, in this, we'll be talking about legal requirements and unique risks that are prevalent within the cloud environment. Now, when trying to understand the legal requirements in a cloud setup, we need to understand a few important points. These are conflicting international legislation, evaluation of legal risk specific to cloud computing, legal framework and guidelines, eDiscovery, and forensic requirements. Now, conflicting international legislation, for instance, if you are GDPR going to be GDPR compliant, and if this law is a conflicting law with another law in another country, then it presents you with some sort of problems, right? You will have to deal with both the federal agencies in both these countries or locations. So whereas GDPR says that any data stored in Europe, any PII data or any such sensitive data that should be stored in European soil itself, it should not be stored outside European countries. So technically, even now, with the exit of United Kingdom, even Britain is also out of it. If you're going to be storing some data in London data center, so technically from a GDPR standpoint, they're out of it. So these are some of the things that we'll have to be very careful about. Now, for US, this is a law and it works in the best of their interest. But for Denmark, probably if the Danish data is going in American data centers and PI data, it could be a violation of GDPR. Whereas as per the Cloud Act, it is absolutely fine. So there can be conflicting international disputes or international laws that can present you with conflicts. And because every country have their own legal jurisdiction, there is no global or defined framework that addresses common international concerns. It's not the case. It is only with encryption. Beyond encryption, nothing else is similar. Evaluation of legal risk specific to cloud computing. So there can be potential legal risks specific to cloud computing. There can be. There could be certain legal frameworks and guidelines and eDiscovery and forensic requirements. So these are some of the important aspects we need to be absolutely clear about and address things accordingly in the cloud world. The simplicity of computing and storage provided by the cloud has led to a complexity of legal issues. And the number one problem around the world is data privacy. Data privacy has really picked up pace from data protection issues from 2015 onwards till now, and they're pretty much new legislation almost coming out on a regular basis. Many countries are adopting certain frameworks, and thereby new regulations are coming out, and that presents you with complexity. Now, you cannot store China's data outside Chinese data centers. However, China expects Chinese firms to provide them with data that may be stored in, let's say, in Malaysia or in Singapore. So there are potential international legislations which can be a potential source of conflict. Now, below is a list of the possible sources of international legislation conflicts that we must keep in mind when we're dealing with legal technicalities in cloud. So, for instance, copyright law, intellectual property, breaches of data protection, violation of patents, privacy-related components, and legislative requirements. So there could be a breach of any of these things. And there could be these 6 areas, there could be a potential violation, especially when you're dealing with international boundaries in any of these 6 areas. That's the whole point. Okay. Cloud computing can be subject to several legal risks. There are a huge number of laws and legislative items which may impact cloud environments, such as legislative law, state laws, copyright law, piracy law. So there can be some anti-piracy laws as well. Now, cloud computing can be subject to several legal risks. When coming up with a legal strategy, these specific laws should be thought of about very carefully. Many of the laws may be location specific, so we need to take that into consideration as well. Also, possible mitigation using certifications and regulatory compliance should be considered carefully. To any extent, you can, whatever mitigation techniques you can do, you should just try to, you cannot completely eliminate risks, especially if you're in cloud. or even generally you cannot completely eliminate risk. But in the world of cloud, there are more areas to cover. Hence, there are more risks that are prevalent. So you should try to minimize your risk to the maximum extent possible. Let's talk about legal frameworks and guidelines. Now, there are several legal frameworks and guidelines which may help in dealing with legal issues itself surrounding cloud computing. Depending on the geographical and judicial location of the users and cloud service infrastructure, different legal guidelines may apply. For instance, if your operations are located in EU, then EU Data Protective Directive may apply. In short, EU Directive 95/46/EC is intended to protect the data privacy rights of European citizens. These guidelines focus on the quality of data, legitimacy of data processing, special data processing categories, the data subjects, data access rights, etc. So there are, in short, they're addressing all data privacy related concerns. Also, to better deal with the legal and privacy related processes, there are few legal frameworks which you can take a look at. For example, the Asia Pacific Economic Cooperation Privacy Framework. Now, the goal of this particular framework is to promote consistency of approach to information privacy protection. This framework is based upon 9 principles. So the principle that we're talking about is the Asia Pacific Economic Cooperation Privacy Framework. And what it talks about is 9 common principles. The first one is integrity of personal information, choice. Let's say you're trying to get access to somebody's information. You're requesting that person to give consent. That person has the right to allow you or not allow you. So it's a matter of the subject's rights. Now, once the consent is provided to you to store that person's information, what are the security safeguards that you as a data controller are having to make sure that the recipient's information is adequately protected? Accountability. So you are accountable for making sure that you as a data controller, because you are holding the data of some individual private data or their personal data. So you are accountable to make sure that security is paramount and the data is adequately protected and accurate information is available when requested. Access and correction. So let's say tomorrow the persons whose data you have stored comes back and will ask you, will want to see what information about him or her has been kept in your systems. You will have to furnish that information. And if there is anything information which is wrong, he may request for correction and you are obliged to carry that correction out. So for instance, if a person has changed their middle name or they've changed their last name, so if they want any correction there, you are bound to do that if you are a data controller. Now, these guidelines and frameworks are there. They help in dealing with legal matters. These are highly subjective to the geographical location and judicial boundaries that apply to a particular data center. You need to do your due diligence in understanding what legal guidelines and frameworks are important for you to understand. So far we actually touched base upon privacy related aspects. The next part is about eDiscovery. eDiscovery refers to any process in which electronic data is sought, located, secured, and searched with the intent of using it as evidence in a civil or a criminal legal case. eDiscovery involves the following main steps. Identification. Data that is potentially relevant to a case is identified along with its location, custodian, size, volumes, etc. Preservation. The identified data is placed under a legal hold, starting the formalized forensic process. Collection. Data is collected from the original custodian, typically by physically removing the original digital storage media. This conversation, these 3 steps, if you purely look from digital forensics within cloud, it throws 2 interesting questions. When you know the original evidence is identified, now typically what will happen is, if this was an on-premise setup, you will physically see that machine and that will no longer be under someone's control. As a part of the agreement, the log is to be kept for 30 days. Now it's the 29th day, or let's say it's the 30th day itself. And that's the time when this preservation is required. Will the data be preserved beyond 30 days, which is agreed? Because it is required for forensics. That is a potential, catch here. It's a catch-22 situation, because as per your agreement with the cloud service provider, so after 30 days, they will not preserve it. They will just rotate the logs. So which means that you will have no longer logs. 30 days preservation time period is over. That would be one thing. And the other thing is, defined in your contract, where it says that preservation of audit logs will be required for digital forensics. So there could be conflicting situations within the contract itself. So at one side it says beyond 30 days it will not be kept. On the other side it says for forensics it may be required. Now, how you deal with this thing? Now, it's a potential bottleneck, because there is no overriding scenario here. One side says, the cloud service provider says, yes, I will preserve the logs, but that's the thing. After 30 days, I'm not required to do so. On the other hand, it says that the logs for any digital forensics investigation that a customer wants, such evidence needs to be preserved by the cloud service provider. Now, in this case, now if such a conflict occurs, if I look out from a legal standpoint, probably the second point, which is that if the customer requests for digital forensics, in that case, probably indirectly, because that part is being said, it's 30 days doesn't matter, but you still need it. If they requested it, you may need to preserve it for longer than 30 days. So if that's the case, the second part of that probably gives a clear answer here. Processing forensic bits are stored in a form that allows them to be searched or analyzed for information that is relevant to the case using suitable forensic tools and platforms. Review. Forensic bit copies are searched or analyzed for information that is relevant to the case. Analysis. The information is further analyzed and assessed as to its relevance, suitability, weight, meaning, implications, etc. Production. Relevant information from the analysis plus the original storage media, etc. is formally presented to the court as evidence. So these are the steps. You first process the information, review it, and you don't directly work on the original evidence. You actually seal it across. You make copies of that.
Just a quick info, guys. Test your knowledge of cloud security by answering this question. Which data may not be suitable for public clouds? A. Legacy application data. B. Mission critical workloads. C. Sensitive data. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
And you analyze the copies on which you have copied the data. You copied the evidence data, right? So then an analysis, and then you produce relevant information from the analysis plus the original storage media. Now, take into account two factors. One is that we are well aware that you can use the hash codes, the hashes. So if X data has a particular hash value, another copy of that will also have the same hash value. At least you can correlate that, because the same hashes, more or less, they produce the same data. If two hashes are the same, it means data on this machine and the data on the other machine is the same. That's the basic assumption. So if you go by that principle, even if you present copies, this could be presented as a valid argument in court. Forensic requirements. For proper cloud security, we must understand and accommodate cloud forensic operations. It has several considerations, such as cloud forensic is a subset of digital forensics based on the unique approach to investigating cloud environments. Cloud service providers have servers around the world to host customer data. When a cyber incident happens, legal jurisdiction and the laws that govern the region present many challenges. A court order issued in a jurisdiction where a data center resides will likely not be applicable to the jurisdiction for a different host in another country. So this is also a potential problem. In modern cloud service provider environments, the customer can choose the region in which data will reside, and this should be chosen carefully. I mean, that's something prerogative of the cloud customer, and they should do their due diligence to make sure where they're hosting this data. In PaaS and SaaS service models, customers must depend on the cloud service providers for access to the logs as they do not have control over the hardware. That's true in PaaS and SaaS. That's definitely true. In the IaaS platform also, there's a defined, 30 days, 7 days, like depending on the cloud service provider, right? So there is a default policy after which the service provider itself will start purging the logs. Understanding privacy issues. Privacy issues in cloud usually stem from misunderstanding or incorrect implementation of one of the following ideas: difference between the contractual and regulated private data, country-specific legislation related to private data, jurisdictional differences in data privacy, and standard privacy requirements. Difference between contractual and regulated private data. Contracted and regulated private data might seem the same, but they are different and they need to be treated differently. Contractual private data is data for which all the parties are contractually bound to only work with provided data in a legally restricted manner, which means the only operations specified in the contract, which is agreed upon by all parties, can be performed on the data by the parties involved. On the other hand, regulated private data is defined as data that requires implementation of specific privacy and security safeguards as mandated by the federal, state, or the local law, or your own organizational policy or any vendor-related agreement. This means that this data can be worked on, stored, retrieved, and worked up under very specific conditions by authorized country-specific legislation related to private data. Now, one has to be very careful regarding this. Now, for example, in Canada, you have to be aware of the data privacy, requirements. This is Canadian. Similarly, if you are in Europe, it is GDPR. If it is the United Arab Emirates in the Middle East, they have their own data privacy law. They have their own privacy this thing. So many countries around the world have their own this thing. In fact, Switzerland being directly under, they have their own data privacy laws apart from GDPR, right? So they have their own specific data protection laws, So for instance, we are well aware that in Switzerland, it's the hub for financial activities, right? It's a financial hub. And whether you go to Geneva or Zurich, you talk about a famous bank like UBS, right? UBS, probably one of the top banks around the world. It's so hard to get customer data there, right? I mean, accounting data, so many countries have requested. And, we have seen for over a century, it was a secretive system, right? So if, let's say, China wants to find out which individuals from China are holding a Swiss bank account or how much money they are holding in Swiss bank, that's something it will be hard to obtain because Switzerland have their own privacy and it operates in very secrecy, right? So it's hard. So apart from GDPR, there's so much regulations around there. Now that some sort of agreements are coming between some countries and they're coming up with that, but still it's pretty hard. This kind of data is pretty hard to obtain. So the whole idea here is that every country could have their own data privacy or data protection laws. One has to be careful around regarding with these laws and be aware. There has to be some sort of awareness regarding that. That's the whole idea. Different countries may have different rules and regulations that govern storage and treatment of private data. In cloud computing, data centers which store data and workloads are usually spread across multiple counties and even continents. Because of this, dealing with private data and the laws applied to them based on the geographical locations can be very tricky. Now, I'll give you a good recent example, something which happened last year. India still does not have any data privacy law, in practice, right? There is a draft bill, it has to be tabled, but there is no such legal provisions around it at this point in time. Last year, that's the case. Last year in 2020, there was a serious concern regarding the social app TikTok, where the concern was that it was storing TikTok application. It was storing the data of customers in India and around the world on Chinese servers. That became the contentious point for the Indian government to expel TikTok out of India. So TikTok and some other Chinese companies, under which there were concerns that they were storing the data of Indian citizens on Chinese servers. So as a result, even though the data protection bill is not yet out, they were out of business last year. So they are pretty much out of India. Yeah, that's right. Personal data protection bill, it's still not completely out. It's not defined, right? So pretty much it. So while it's not completely out, and still this happened, right? And there are concerns around with other Chinese companies, specifically Hikvision, which is the one of the world leaders when it comes to the CCTVs, right? So there is a serious concern regarding how Hikvision, may be storing it. So here, in many parts around the world, for example, there are CCTVs that are deployed on the roads, specifically because if people are overspeeding, your Hikvision CCTV cameras can make those notes or can capture those details, like automobile numbers, the vehicle numbers, and then these people can will be liable to pay some penalties if they're over speeding or something like that, right? And even when these are deployed around some cities here in this part of the world, there is a serious concern that Hikvision is actually sending this data in Chinese servers. Same thing happened with Huawei, right? I mean, why Donald Trump was so aggressive around the fact that Huawei 5G's infrastructure was capturing, it had a lot of security concerns, and it will capture some of the user details and will be sending this data to Chinese servers. Potentially, that was the reason why it was kicked out of US, and it never came, it was never allowed. And it's pretty much out of business, at least in pretty much in Canada, at least in front of 5 Western countries. Like it's out in Canada, it was never established in US, never established in Australia, New Zealand, and UK also. Britain also kicked them out, and there's now a chance that countries like Germany would also follow suit, right, where they may not be adopting their 5G infrastructure. So you see that these are the concerns around the world. Okay, let's move on. So each geographical location may have their own legal rules and regulations for data privacy and protection, which needs to be followed by the cloud service providers. For example, EU maintains that the GDPR applies to the personal information of all EU residents where they might be located. And these nomenclatures are also changing. Now, for instance, with Britain, they have exited the European Union. And there are certain data centers, Azure maintains it in London, Southampton, they all maintain certain data centers in UK. Now, what will happen with the Britain's exit? So if some of the, whatever customers data was there in this thing, let's assume that the UK data center was used as a backup data center for the data that is hosted in Netherlands. So now with UK exiting the EU, what will happen to those customers whose data is there in UK data centers? Now it's officially out of EU, so would that also be treated as a breach? What will happen to that kind of things? What provisions are there in place? So jurisdiction, another thing to keep in mind when dealing with legal rules and regulations that apply to data centers and data stored in them is the jurisdictional rules. Jurisdiction is the practical authority granted to a legal body to administer justice as defined by the kind of case and the location of the issue, which is to say the location of the data center may also determine which legal bodies have authority to dictate rules related to the management of private data. Now let's talk about something interesting in regards to this international laws. Okay, let's talk about a country called Austria, which is near to Germany and near to Poland, nearby Czech Republic. They have some very interesting laws actually. Now what they say is crime is committed by any Austrian individual, okay, in Austria or in any part of the world beyond Austria, they will be held accountable for that guilt, for that breach of law. So let's say if an Austrian citizen is in Singapore, right, and this citizen is earning good money, and let's say they violated this resident violated some law, right, some data privacy legislation in Singapore, and then for his holidays he goes to Australia, and before he comes back he realizes that some people inform him that, hey, did you do something like this? And now this person is stressed and he doesn't want to come back to Singapore. He is happy back in Austria. He probably look out for some other job. He's just happy there. A data, any such breach which involves some sort of digital computer crime that's being committed by an Austrian resident in Singapore. And even if Singapore and Austria do not have any extradition treaty, any crime committed in Singaporean soil by an Austrian, that person will still be held liable, guilty within Austria itself. Now, that's really fascinating because no such country around the world, at least as far as my limited knowledge goes, has such provisions. Austria is definitely one exception. So beyond its boundary, it does recognize the norms or the laws of the other countries. And if their own citizens commit a crime in another country, irrespective of how grave the matter could be, a crime is a crime. That's the notion they go about. It helps to resolve international conflicts because that's the way to go about it. Standard privacy requirements. Depending on the geographical location, there may be several guidelines, regulations, and practices which you may need to follow. Here are 3 of these. You can take a look at that. ISO 27018. You can look at GAP. You can look at GDPR. ISO 27018. This document establishes commonly accepted control objectives, controls, and guidelines for implementing measures to protect PII data for the public cloud computing environment. The objective of this document is to assist the cloud service customer and the public cloud PII processor in entering into a contractual agreement. The guidelines in this document can also be relevant to organizations acting as PII controllers. So this can help you. GAP, Generally Accepted Privacy Principles, is a framework intended to assist chartered accountants and certified public accountants in creating an effective privacy program for managing and preventing privacy risks. The framework was developed through a joint consultation between Canadian Institute of Chartered Accountants and American Institute of Certified Public Accountants to the AICPA CICA Privacy Task Force. So it's GAP is a common principles between US and Canada. It's applicable within North America. The GAP framework was previously known as the AICPA/CICA Privacy Framework. It is founded on a single privacy principle that the PII information must be collected, used, retained, and disclosed in compliance with the commitments in the entity's privacy notice and with the criteria set out in generally accepted privacy principles issued by these 2 bodies. Then you have GDPR, which is came into effect in 2018. It's a regulation in EU law on data protection and privacy in European Union and European Economic Area. It also addresses the transfer of personal data outside EU and EE, European Economic Areas. The GDPR's prime and the sole aim is to give individuals control over their personal data and to simplify the regulatory environment for international business by unifying the regulation within the EU. The GDPR 2016 framework has 11 chapters concerning general provisions, principles, right of the data subject, duties of data controllers or processors, transfer of personal data to third countries, supervisory authorities, cooperation among member states, remedies, liabilities or penalties for breach of rights, and other miscellaneous final provisions. Now you see the term data controllers and processors. Data controller is a person who is storing your data, who is requesting for access to your data, request for consent, and they are storing the data. Data processors are the people who access your data on behalf of data controllers. Okay, so that's difference between the definition of a data processor and a controller. And GDPR came into, it was being defined around 2016, finally came into effect in 2018. Understanding audit process methods and required adaptations for a cloud environment. So let's talk about this part. Auditing in cloud computing is very important. There are several aspects to it that we need to understand. The internal and external audit controls, the impact of audit requirements, restrictions of audit scope statements, gap analysis, your policies, internal information security control system, identify assurance challenges of virtualization cloud, audit planning, identification and involvement of relevant stakeholders, impact of distributed ID model, type of audit reports, internal information, your ISMS, and specialized compliance requirements for highly regulated industries. Now, a simple point to consider here is if you are going for a important assessment, you could always go for a star cloud audit. Okay. It's the one of the most comprehensive and one of the best audits, that you can get around. So star audit is, this is what I was talking about. Actually. You can go for this is a star program, right? You can go for a star level 1 audit and all those kind of things, right? So a company that is star certified like BSN, they can do a star audit for you. And they will do it on the basis of your cloud control matrix, right? So it's the one of the most comprehensive it's CCM, cloud control matrix, and they will check around all these security domains, which is quite comprehensive in its own right. So it'll be all around this. Internal and external audit controls. Now, audit can be of two types. You can go for internal audit, you can go for external audit. Internal audit is obviously performed by your own people. Audits performed by a designated company employee to make sure all operations are following standard practices and logs are being maintained. For example, you can get somebody from your dedicated cybersecurity team to do an audit. If it is a CISO, can get some of his staff members to conduct an audit for you, right? To conduct an audit for your applications, which is hosted in the cloud. And then comes the external audit performed by an external entity elected by stakeholders, by company stakeholders, to check and verify operations and standards are being met. So that is the external audit. Now, what is the impact of audit requirements? The nature of cloud computing has made auditors reimagine how they audit. Auditors now have to worry about several questions such as, what universal population do we sample from? What are the sampling methods for this? How to tell if the virtualized server that you're auditing is the same as it was before? So identify assurance challenges of virtualization. So there are three main challenges in service assurance in the virtualized cloud environments. One is ensuring that the data acquired from a network and its processing happens in real time. So that's number one. Number two is building service models that are always synchronized with the state of the network. And number three, converting network or oblique service data into meaningful analytics to serve the business objectives. So these are the three main challenges in service assurance. The thing is that the only factor that is within your control is the fact that you can create certain metrics by the help of which you can count. So for example, if you have a production server and you have a standby server, you can take into account things like the latency factor, all those kind of things. But always remember that you don't have complete physical access. So to get real visibility into things like how much of this is happening real time, you will not have all the metrics available at your disposal, especially when you're setting up these kind of services in the cloud. If the same was in your on-prem data center, it was easier to calculate or get those metrics, but the same is not holding true for the cloud world. So let's take a look at the types of audit reports. Now, there are three main types of audit reports that are important for cloud computing audits. You have SSAE, which is pretty much now. It's been replaced by SOC reports, and you have ISAE. Let's talk about what are all of these. Now, SSAE stands for Statement on Standards for Attestation Engagements. It is an auditing standard for service organizations produced by American Institute of Certified Public Accountants Auditing Standards Board. This standard is used to produce system and organization control reports. Earlier this used to be the norm, but this has long been replaced by SOC reports. So in SOC, you have SOC 1 reports, SOC 2 reports, SOC 3 reports, those kind of things, right? SOC 1 reports are basically for financial standards. SOC 2 is more about controls related to your IT setup. There are 5 parameters for SOC 2, it will look into things like the trust factor and all those kind of things specifically. SOC stands for Service Organization Control. It is, these reports help companies to establish trust and confidence in their service delivery process and controls. Again, these reports are administered by an independent third party that must be a certified public accountant. And by the way, SOC is the benchmark, this certification is attested by AICPA, American Institute of Certified Public Accountants. ISAE stands for International Standards on Assurance Engagements. Now, International Standards on Assurance Engagements is an international assurance standard that describes SOC reports which give assurance to the organization's customers and service users that the service organization has adequate internal controls. SOC stands for Service Organization, here it is, control, okay? Now let's just go a little deeper into this discussion about SOC and, let's just talk about ISAE, right? Now, before I explain the difference, just take a minute or so to read the definition for, or just read the narrative or the description provided for ISAE. So International Standards on Assurance Engagements, ISAE, it's an international standards that describes SOC reports which give assurance to the organization's customers and service users that the service organization has adequate internal controls. So first of all, ISAE internally utilizes SOC reports, and it's an international assurance standards that prescribes SOC reports which gives some sort of attestation to any given organization's customers that this company has got adequate internal controls. So ISAE internally utilizes SOC reports. That's what they say, and they say that it's a nomenclature that's being used. Now, what exactly is SOC reports? Let's just understand certain differences between type 1 and type 2, right? Now, you have something called as SOC. First, let's talk about SOC type 2, type 2 report, right? Now, what is it exactly based upon? 5 factors, right? Okay. So 5 trust criteria for SOC 2. So you see here, you have different variations of SOC. You have SOC 1, SOC 2, SOC 3. And within each one of them, you have different, SOC 1 type 1, SOC 1 type 2, SOC 2 type 1, SOC 2 type 2, right? Now, instead of getting into the intricacies of entire SOC, because what we are going to just understand is the differentiating factor between SOC versus ISAE. Now, I'll talk about SOC 1 and SOC 2. Let's start with SOC 2, what exactly it is all about. Now, SOC 2, if any organization goes for SOC 2, it is basically an audit process that relies on 5 categories. So there are 5 factors for trust service criteria. So it is looked from the aspect of security, availability, data availability, application availability, confidentiality factor, integrity factor, and privacy factor. So 5 critical areas, 5 trust areas: security, availability, confidentiality, processing integrity, and privacy. So you got to have the right controls in all these 5 areas to make sure that you are SOC 2 compliant. Right? Now, what is SOC 1 report? Right? What exactly is SOC 1? SOC 1 is a report on controls at an organization which are relevant to user entities' internal control over financial reporting. So it's in simple, SOC 1 basically refers to controls related to financial reporting. SOC 2 report focuses on controls, internal controls related to 5 criteria factors, 5 trust criteria factors. Those factors are security, availability, confidentiality, integrity, and privacy. So it's based on, so it looks out for internal controls in these 5 areas, right? And this is SOC 2. You have SOC 1, which is focused on internal controls related to financial reporting. Okay. So now when we come back to this, what is international standards for assurance engagements? International standards on assurance engagements is a standard which prescribes SOC reports It could be SOC 1, it could be SOC 2, any of these, which give assurance to a particular organization's customers and service users that the service organization has adequate internal control. SOC 1 relates to internal controls related to financial reporting for a given organization. SOC 2 is more on the IT related controls for 5 critical factors, which include security, availability, confidentiality, integrity, and privacy on these 5 related areas. Now, restrictions of audit scope statements. There are several restrictions of auditing in cloud computing, such as you need to rely on experts. An auditor has to rely on experts like engineers and lawyers for estimation and valuation of fixed assets, estimation of contingent liabilities. Now you see why it's a potential challenge, because the server is hosted on the cloud. So if a server is procured in-house, you would probably add up its cost at that moment. So if it is a new machine that has been procured, during given year, or if the value of that particular server is being depreciated over a period of time, you will take into account all those factors, right? Now, the fact is that there's a slight difference, because think if you are going to have a data breach, now your server is very critical, right?
Just a quick info, guys. Intellipaat provides CCSP certification training, mentored by industry experts, the course link of which is given in the description below. Now, let's continue with the session.
But what about the server that is holding the data? So its price, maybe it could carry a heavy price tag because of the critical nature of the data that is getting stored on that. But it is also possible that the server itself, which is hosted.
Just a quick info, guys. Test your knowledge of cloud security by answering this question. Which data may not be suitable for public clouds? A. Legacy application data. B. Mission critical workloads. C. Sensitive data. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Which has been hosted in the cloud is not having new generation hardware architectures. It's a virtualized server with running on cheap hardware, right? So those are some of the things you will have to reach out to experts for cost estimation and all those kind of things. Efficiency of management. An auditor does not comment on the efficiency of management working in client organizations. No comments on future performance of an organization can be made through audited financial statements. So keeping the management away from the purview of the auditor, it's always kept out of scope, right? Checking of all transactions. Now, it is not possible for an auditor to check all business transactions, especially in their organizations, where the number of transactions is very high. An auditor has to rely on sampling techniques and test checking. You will not have the bandwidth to check out all the business transactions. Probably you can take a sample, or you can sample a given period of the transactions, and you can sample on that basis and come up to some conclusions or some findings. Additional financial burden. An organization has to bear additional financial burden on account of any fees and other such expenses for conducting an audit. So the auditor also will come and charge your organization some dues. So your organization will have to consider these aspects as well. It is not easy to detect some frauds. It is not easy for an auditor to detect deep laid frauds like forgery, missed statements and non-recording of transactions. So if any of these things have happened, it just makes the job of the auditor even more difficult. Gap analysis. Now, what exactly is gap analysis? It's a method of assessing the differences in performance between a business's information systems or software applications to determine whether business requirements are being met, and if not, what steps should be taken to ensure that they are met successfully. Gap refers to the space between current state and the target state. So where you currently are and where you want to be. So it just talks about the gap between your present state and the futuristic target state. Our gap analysis may also be referred to as needs analysis, needs assessment, or need gap analysis. There are several tools and frameworks such as the McKinsey 75 framework, which can be used for gap analysis. Audit planning. So let's talk about this. An audit plan is the specific guideline to be followed when conducting an audit. It helps the auditor obtain sufficient evidence for the circumstances, helps keep audit cost at a reasonable level, and helps avoid misunderstandings with the client. The auditor plans to perform the audit in an efficient and a timely manner. So audit plan contains the guidelines to be followed during the process of the audit. Now, it will help the auditor to obtain a good deal of information or good deal evidence for the circumstances, and that will also keep the audit cost also at a reasonable level, and it will always avoid any misunderstanding. So audit plan is a very important aspect. Now, what does audit plan include? It includes the following procedures: knowledge of the client's business, which includes financial, legal framework, government norms, investments, accounting policies, business risk and financial risk, development of audit strategies or overall plan, preparation of audit program. Now, we've been talking about things like, as a part of the audit planning, you should take into account, all these factors. Let's say you are doing an audit of a banking application, and let's say you are doing the audit for mortgage. So what all things you would need? You would need certain reports. Here you would need, financial reports. You would need some certain metrics, some internal transaction reports, and all those kind of things, so that it helps you to understand the current setup and ask questions accordingly as a part of your questionnaires, or find evidence accordingly. So these are the things that will serve as an input. So audit planning is all about that. And the more insights you can get during the planning process, it will really help to cover seamlessly things, when you actually start the audit cycle altogether. Internal Information Security Management System. Let's talk about that. An ISMS, which is an Information Security Management System, is a set of policies and procedures for systematically managing and organization sensitive data. Now, the goal of an ISMS is to minimize risk and ensure business continuity by proactively limiting the impact of a security breach. Now, what sort of policies? Let's just talk about it. Let me show you an example here. Okay, let's just see from a governance standpoint, and something that you will be. Let's take Salisbury University as an example. Okay, let's take their security policy management. Okay, so we go here, right? It will probably download the data security policy. Now, I'm not interested in that. I just want to take a look at if I can get a chance to look at some of their policies. That's the whole idea. Okay, so we can see there are a lot of policies here around. So there is something called a security policy management. You can see that they have a lot of IT related policies like account management policies, the cloud service security policy, configuration management policy, and so on. I'm more interested in this particular policy, security policy management. Okay. Now, what is this is all about? Now, you can see this organization, this university has got all the following policies referred to as the overall IT security policy. So they have got an account management policy, they have an asset management policy, they have a data security policy, they have a cybersecurity incident response policy, they have a configuration management policy, they have a wireless access policy, they have a remote access policy, they have a security assessment policy, they have a media protection policy, they have an endpoint protection policy, they have email security policy. So that should answer any such question. So your security policy management document, it just provides context to all the other related policies. And this entire set of policies makes up your overall information security management system. That's the whole idea. Now, the goal of an ISMS is to minimize risk and ensure business continuity by proactively limiting the impact of a security breach. So if tomorrow, if your organization encounters a security breach, the whole idea is that the things that will be checked around would be some audit log entries. You have, who did what at a given time, all those kind of things. And ISMS typically addresses employee behavior and processes as well as the data and technology. It can be targeted towards a particular type of data, such as customer data, or it can be implemented in a comprehensive way that becomes part of the company's culture. Internal Information Security Control System. Information security controls are measures taken to reduce information risks such as information system breaches, data theft, and unauthorized changes to digital informations or system. These security controls are intended to help protect the availability, confidentiality, and integrity of data and network, and are typically implemented after a information security risk assessment. This is quite comprehensive, and it's comprehensive enough to the point where a lot of security related checks, if due diligence is done, you will be getting a tick across many security domains that are covered by the CCM control, cloud control matrix. And this is how, and your goal is to figure out the security controls under all these areas, audit and assurance, application and interface security, business continuity management and operations resilience, in logging and monitoring, security incident management, eDiscovery, and cloud forensics, all these kind of things. Okay. Internal information security controls systems are systems which can be used to automate the application of these controls. These systems speed up the application and management of security and data collection policies in internal systems. An audit policy defines account limits for a set of users of one or more resources. It compromises rules that define the limits of a policy and workflow to process violations after they occur. These policies may be grouped into several levels or groups such as organization, functional, cloud computing. These groups can have different auditing requirements and different auditors as well. Now, an account audit policy defines account limits for a certain set of users of who are allowed to access one or more resources, and it comprises of rules that define the limits of a policy and workflows to process violations after they occur. These policies can be grouped into several levels like organizational, functional, and cloud computing. Identification and involvement of relevant stakeholders. In the auditing process, relevant stakeholders should be involved. These stakeholders must be first identified based on the resources being audited. After the identification of these stakeholders, they should keep in loop of any relevant updates on information found during the auditing process. Active involvement of stakeholders is expected to make the auditing process more successful. Now, specialized compliance requirements for highly regulated industries. Let's talk about this. Based on the kind of data being stored, there are times where we have to follow several regulations in storage and data retrieval. These regulations may be geographical, like in North America, could be in payment card industry, or sensitive data as well. As a part of the specialized compliance requirements, these regulations are maybe more geographical in nature, right? I mean, the jurisdiction of that will be geographical in nature. So whether you're doing it from a perspective of critical infrastructure protection or industry-based, like payment card industry standard, and many such things. Now, auditors need to especially be cognizant of the regulations that apply on the data as well as the infrastructure in which the data is stored. Auditors also need to do proper verification of the compliance of these highly regulated, especially based on the industry that the data is concerned. Now, if you are a healthcare provider, one has to be, as an auditor, I'll have to be very extremely careful to make sure that wrong information is not passed through in such cases, right? So auditors should be aware of the regulations that apply on the data as well as the infrastructure where the data is being stored. So for example, privacy related, so any privacy related challenges can be well addressed, by doing due diligence here in such cases. Impact of distributed information technology model. Let's talk about that. Now, since cloud computing is spread across a wide range of geographical locations, it further complicates the auditing process. Based on the geographical locations, different laws may apply to the data and the infrastructure. The legal jurisdiction may be vary based on the location as well as the data being stored on the infrastructure. Auditors will have to understand the legal and jurisdictional aspects of the infrastructure and data being stored on and proceed accordingly. So auditors will have to take into account any such legal or jurisdictional related aspects accordingly. Understanding implications of cloud to enterprise risk management. Now, there are several factors we need to consider when we talk about enterprise risk management and cloud computing. We need to assess the service providers' risk management programs. We need to understand the difference between data owner and data custodian, regulatory transparency requirements. Then you have the risk treatment. Then you have different risk frameworks. You have the metrics for risk management, and you have then finally assessment of risk environment. All these factors will come into play. Assess providers' risk management programs. Many cloud computing service providers provide risk management programs. These programs may need to be evaluated by the auditors as well as the stakeholders. These programs should be evaluated on the following parameters such as controls, the internal security controls, any methods, and any such policies. It should be made aware that these programs can provide desired value to the organization and support their expectations. So let's cover the difference between data owner and data custodian. Now, data security is a complicated problem, and many people across the organization play different roles in the data security process. The data owners are the business leaders with overall responsibility of data centers. They set policies and guidelines for their data sheets. Then you have data custodians. So they are the people who actually store and process the information. They are often referred to as IT staff. Risk treatment. Now, there are 4 options to treat or deal with the risk. So the point is very simple. Whether you go for risk avoidance, sharing of risk, modification, retention. So these are the 4 options, but you cannot completely eliminate risks. You can mitigate them. You can lower those numbers, but you cannot completely eliminate, risk scenarios. That's not possible. So let's talk about what are the 4 options to deal or treat with the risk. So avoidance, changing organizations' business practice to remove the possibility that the risk is affecting your business. Sharing, shifting the impact of the risk to another organization, like such as insurance policy. Modification, reducing the likelihood or impact of the risk. Retention, we can accept the risk without taking any further action. Regulatory transparency requirements. Dealing with audit regulations can be tricky, and it is very important to understand that several regulations demand high level of transparency about data with the customers. There are several legal acts which make transparency between parties compulsory, such as Sarbanes-Oxley Act of 2002. Several guidelines require strict deadlines for sending notifications in case of data breach. For example, GDPR states that in case of the personal data breach, the controller, which controller? Data controller, somebody who is requesting your personal information and you have approved that you have given your consent for the third party to store that. Now, if the data controller's environment is breached, then as per the GDPR rules, the controller shall, without undue delay, not later than 72 hours after having become aware of it, notify the personal data breach to the supervisory authority. So they should notify this to the supervisory authority. So this is also a regulatory requirement. In some cases, there would be a need to report certain things. I'll give you an example, right? Recently in India, they introduced a new requirement that all the social media companies, and pretty much on the cloud, they don't, they have either their own cloud-based data centers or they are storing it on AWS or other platforms. The whole idea here is that companies like, Twitter and other firms, they were mandated in India roughly around in the month of March, April, earlier this year, that they need to have a compliance officer, which is a chief compliance officer based in India. And every 2 weeks, that person, the chief compliance officer of these social media companies, they have to share a report, a compliance report with the government. So that's a regulatory requirement, right? And it's a mandatory regulatory requirement. That's just a new development which happened this year. And such developments could be happening, or such provisions may be there in other parts of the world, that you have to follow some compliance with the regulatory bodies. This has become the norm here. In GDPR also, there is a certain criteria that after 72 hours, of the controller being aware of any data breach. They have to report it to the supervisory authority. And there are such several regulatory restrictions around the world. You don't have a choice. You have to just comply with that, right? So that's the whole idea. Now that can bring an additional layer of challenges, these regulatory requirements. That's the whole thing. Now there are different risk frameworks. Risk management frameworks provide proven time-tested techniques for performing enterprise risk management. Organizations can create their own risk management frameworks if they do not find any framework fit for their use cases. One of the most widely used risk management framework is NIST Special Publication 837. So this could be used, any of the NIST standards, special publications that are out, they are all self-adopted, right? There is no, it's not a certification which you have to acquire, right? They're all self-adopted. You can adopt it and you can tweak it according to your organization's requirements. So NIST 837. The other famous example would be, take an example of fair risk assessment. That's also pretty good. So if you want to check this out, you should check this out. In fact, as of now, there are some recent developments happening on this. So anybody, if you want to take this out, there is some partnership that is happening between RiskLens and NextGen Talent. So there are some discounts happening, So if somebody wants to take fair training, get acquainted with the fair risk assessment, you can go for it, if it suits you. Anyways, like similar to NIST 837, FAIR is also a pretty standard or a well-known risk management framework. Okay. Now what the risk management process do? They have 6 steps in NIST Special Publication 837. NIST is nothing but a series of special publications. They have certain things for risk management, they have for disaster recovery, they have for cloud computing. They cover a variety of areas. So what are the 6 core steps? Categorize information systems, select security controls. So first you categorize your information systems. When I say categorization, what I mean is you should have a proper structure in place. You should have an inventory. You should define which are your critical assets, non-critical, what location these assets are, who is the business owner, all those kind of things. Right? So once you have laid out that categorization, you need to select security controls. Now it's prudent to say that any of the assets that are of critical, considered critical. When I say critical, we're not talking from a risk point of view, but what we're talking about is from business critical. The assets that are considered more business critical, they will have the requirements for more enhanced security controls are applicable to them. So any organization will have better security controls for the critical business assets as compared to the security controls for less critical assets or not so important assets, right? So the amount of security controls, the higher the criticality of the asset, the more fine-grained the security layer would be. That's how it is. So you define security, you categorize information systems, select the security controls. Then you implement those security controls. So for example, if you have a server which is very demanding, let's say it carries a server has data and that data is worth, let's say, $500 million. Now, if there's something that happens onto that server, this is the amount of monetary loss that a company could suffer as a result of a breach or as a result of unavailability of that server. So you would need to have very strong security controls. What kind of security controls? You want to make sure that there's a very strong layer of encryption there and any other security controls beyond that. A very strong authentication process is established there, all those kind of things. This server got to be protected by your next generation firewall and any other pillars, security layers in between that can maintain the security posture of the server. So categorize information systems, select security controls, implement security controls, access the security controls. So if you want to be deploying a firewall, so any request that comes to this particular server has to first go through the checkpoint firewall. And if it is a valid request from the firewall, it will be then routed to the next security layer or directly to the appropriate organization server. So this is what we're talking about. Then you need to authorize information systems. You need to have a strong layer of authorization. So make sure that proper user credentials are being used, proper access mechanisms are a good layer of security and authorization and authentication is established. And then you need to monitor security controls. You need to make sure that whatever security controls that you have defined, they're being monitored. So for instance, if you have deployed an intrusion detection system, you need to make sure that what kind of alerts that may be throwing up. Are those false positives? Are those alerts, false negatives? Are they true positives, true negatives? This is the entire 6-step process. Metrics for risk management. There are several metrics for risk management, such as asset value, exposure factor, single loss expectancy. Now, asset value obviously is the monetary value of an asset. Exposure factor is the expected percentage of damage to an asset. So here in this case, if we talk about, let's say there was fire in the building, or let's say, so what is the amount of loss that happened to a specific asset like a server, or if multiple assets like to the entire data center, what is the amount of loss? So what percent of damage that happened to the asset? Single loss expectancy is expected dollar loss if a risk occurs one time. So exposure factor is different than single loss expectancy. In exposure factor, we calculate the percentage of damage to an asset. It's not expressed in monetary terms. It's expressed as if the asset's condition is 100% right now, how much percentage of the damage was that happened to that asset. So whether 10%, 20%, 30%. And single loss expectancy means that the monetary amount of loss if a risk occurs one time. If that threat, you had a threat perception, but threat really occurs, right? So you're facing a real-time threat now, and that actually happens. So what's the amount of monetary loss? So that's the single loss expectancy. Assessment of the risk environment. So when assessing risk in a cloud environment, there are 3 kinds of risk we need to consider: service risk, vendor risk, infrastructure risk. Now the point is that you as a customer will not have that much benchmark to check out the locations, because where you're hosting up. So let's say if the cloud vendor is leasing some infrastructure for some monthly charges to you as a customer, you can't go to that data center, but at least you can get a fair estimate as to, let's say if you open up a data center, if you're hosting your services in island data center, you got to be aware about at least some of the semantics in that particular location from a risk assessment point of view. You got to be aware of some of the challenges there. I think if we are aware about these kind of things, we can decide on where to host our applications. We can choose in a better way. So service risk, vendor risk, infrastructure risk, and to add to that also the physical risk factor. While you are no longer in control of the data center here, choosing a data center where you're going to be hosting your services, at least you can benchmark that. At least you can get some idea regarding the conditions there. All you need to do is a bit of searching, right, on internet. So these are some of the risks that are prevalent in when you think about service risk. Could be vendor risk. We talked about, even if you're storing your data itself, you're storing the encryption keys also, entire repository is under risk, right? So service risk involves a cloud service such as a server or database going down. This needs to be tackled using redundancy across geographical locations. Now, the whole idea is that, let's say you have a standby setup in another cloud region from a cloud vendor. Now, the point is, we are talking about the global supply chain. Okay. Now, if a CDN vendor on which these cloud providers like Amazon and many others, and Fastly is not just one of them, there could be many other such vendors, on which these large organizations, including the CSPs, are dependent for their supply chain. If something breaks in the middle, does this ground really hold true? I mean, are you really getting redundancy in the first place? Is that really a correct assessment? So for instance, if you have set up a database server in one region and you have set up a standby database server in another region, and if an outage like what happened with Fastly happens, is it guaranteed that the assumption under which you are as a customer, that, hey, if something happens to my production server in one region, I have a backup, or I have a standby server in another region, Could a outage like a global outage like Fastly can change that narrative? Is it a false impression for a customer? I mean, that's the thing, because people are building up cloud services. And if there is a breakdown in the global supply chain, so while you're aware as to how to get onto the cloud, you're well aware of to like how to set up services. People, most of your, well versed in the cloud. I see that there are certain people who are on the cloud architect role or who have a good background generally. They've come from good infrastructure or some other background. Vendor risk is where there are several risks that involve cloud vendors, such as use of insecure hardware or software. There could be a small misconfiguration issue, and that can compromise. The whole idea is that there could be some vendor risks that have the potential to cause some real damage. Then there is infrastructure. So you got to cloud infrastructure needs to be protected from various things such as fire, water, etc. To make sure that the infrastructure is protected against these threats. Make sure to follow guidelines related to laying out and managing cloud infrastructure, such as ASHRAE guidelines. ASHRAE is a series of data center guidelines. Understand outsourcing and cloud contract designs. When thinking about outsourcing and contract designs, there are a few terms that we must ensure that are present in the contract that have been created. These are business requirements, vendor management, contract management, and supply chain management. Business requirements. When thinking about outsourcing contract design, we must ensure that following things are present in the contract. Important clauses should be present in the contract, right? So when you're looking at your service level agreements, you have to be very explicit regarding what you need, not just a generic SLA that the cloud vendor is providing. SLA, as we know, is an agreement which specifies particular requirements of the service being provided and also what the user is expected to do. You also have something called as a statement of work and a master service agreement. A master service agreement, also known as framework agreement, is a contract reached between two parties in which the parties agree to most of the terms that will govern future transactions or future agreements. SOW is a document within a contract that describes the work requirements for a specific project along with its performance and design expectations. SOW is basically more widely used with, so for example, if you are a company like Accenture and tomorrow you want to do business with Bank of America, or let's say with Deutsche Bank. So Accenture will try and get their people on the project of, let's say, with Goldman Sachs, or for that matter, with Citibank and many such companies. So that is the statement work. So what each resource is supposed to do, those, how many resources, and that planning is all covered in SOW. So generally, this is a classical document that is getting used in outsourcing agreements. Vendor management. When dealing with the vendors, we should have clearly stated rules and restrictions that the vendor must agree to. Agreement should clearly specify data ownership. Customers should retain uninhibited data ownership. Vendors' right to use the information is limited to activities performed on behalf of the customer. Vendors should be limited in their data sharing practices with third parties. Also, I want to add here, if you as a customer want to perform DOS attacks, do pen testing, on your cloud applications, Microsoft doesn't want you to perform DOS attacks, DOS pen testing, Azure. They will not allow it, right? It allows you to pen test if you want to perform against their own applications. DOS attacks is out of it. You cannot run DOS attacks. You can see here, the following acts are prohibited as a part of the pen test: analyzing or testing assets of other Microsoft customers, which is signed; running DOS denial of service attacks that generate, or any test that generates a large amount of traffic. What is the definition for a test that generates a large amount of traffic? Microsoft can test it, you can't test it. See, it makes sense to not to conduct DOS attack. Okay? But the point is, what about the second line? This is not making sense, right? This sounds like being hypocritical, right, on part of Microsoft. Contract management. When dealing with cloud contracts, we must take care of several things, such as the contract should clearly define any terms used in the contract. Performance metrics like uptime, availability should be defined in SLM contract. It should clearly state what happens if the vendor fails to live up to its own obligations. It should include compliance and obligations in contract terms. Customers should retain the right to audit the vendor's performance. Customers are not getting the choice to audit the vendor's performance, right? Indemnification or reimbursement clauses should be carefully negotiated. Contract should specify their end and renewal processes to avoid confusion. Contract should specify litigation terms. Where would the litigation take place if contracts are broken? Supply chain management. As vendors provide the supply chain for our cloud services, we must deal with vendors in a way that protects the confidentiality, integrity, and availability of our data and ID workloads. We need to make sure that the vendor security policies are at least as stringent as our own. Now, see, there are a lot of conflicting scenarios, like, and that is a added complexity. So, that's the reason why even after a decade of cloud, technically it started in 2006 with Amazon. That was not really the time. It really started in 2010, 11, mostly in 11 onwards till now. So even in this 10-year or decade-old year journey with cloud, what seems, there are a lot of gray areas, especially the right to audit from a customer side. You want to audit the cloud vendor because they are hosting your own data. Then I showed you this hypocrisy of Microsoft, where to me it sounds like hypocrisy. So, pardon my words, but it is a hypocritical scenario where Microsoft can test their own environments against, they don't require your approval from 2017. So which means prior to 2017, they requested permission. So what changed on that date? And you can't DOS test, or you can't generate some test that generates a huge amount of traffic. And we need to make sure that the vendor security policies are at least as stringent as our own. Make use of vendor management lifecycle. It includes the following steps: vendor selection. Make sure you include our security requirements in the request RFP documents and assess the vendor's risk management program before selecting a vendor. Onboarding. When onboarding a vendor, make sure that the contract details are verified and the data transfer to the vendor systems and services is secure, and that incident procedures are established. Monitoring and offboarding. For monitoring, make sure you conduct regular site visits and audits. You also need to review independent audit reports and make sure that even minor security incidents are being handled. Offboarding. In the offboarding process, make sure the vendor is destroying the confidential information so that it cannot be misused.
Just a quick info, guys. Test your knowledge of cloud security by answering this question. Which data may not be suitable for public clouds? A. Legacy application data. B. Mission critical workloads. C. Sensitive data. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Now let's take a look at data dispersion. Data dispersion is used to store multiple copies of data at multiple locations. In cloud, there are two ways of doing it. First is called bit splitting. Second is called erasure codes. Both of them are quite popularly used in storage systems. They both have their own pros and cons, and they both have their own special way of working. Essentially, what we try to do with these is that we create some sort of redundancy. So once the data is stored in multiple locations, if one location goes down, other locations can be used to rebuild the data, or other locations can be used to provide some backup. In any case, let's take a look at them one by one. So first comes bit splitting. Bit splitting is like adding encryption to RAID. RAID stands for Redundant Array of Independent Disks. Here we store data in an array of disks, and it allows us to store data in a more secure way. Similarly, bit splitting works much more like that, but with encryption added to it. The data is first encrypted, then separated into pieces, and the pieces are distributed across several storage areas. This is so that even if one of the storage locations gets compromised, the person who has the compromised storage location cannot access the complete data. He can only access a chunk of data, which may not be something useful for them. Bit splitting carries the following disadvantages, however. Processing is CPU intensive. So once you have uploaded the data, if the data is of huge volume, splitting it and performing bit splitting on it, which includes processing intensive tasks such as encryption and chunking the data, and then spreading it across multiple locations. All of this is a CPU intensive task, so it cannot be done for a lot of devices, for a large volume of data, for a lot of users. Availability concerns are all part that the data needs to be decrypted before you use the information that is contained inside the data. So you need to be able to understand that all parts of the data are available, so that when you decrypt the data, it is completely decrypted and the entire information is presented in front of you. Storage requirements and costs are higher than other systems because it takes time, it takes effort, and you need to store multiple shreds of the data in multiple storage locations. You need to have multiple storage devices all attached to each other, maybe in separate geographic location. That's completely up to you, but that's one way of doing it. Now, here's how bit splitting works. These are the steps. First things first, we encrypt the data. This is done to make sure that the data that is sensitive is becoming data that is incomprehensible. So encryption basically uses a key and converts plain text to ciphertext. Plain text is the data we have, ciphertext is the data that we want. That's something that people can't comprehend, and it becomes something that people cannot understand. Then we split the encrypted data into chunks. Chunks are basically small pieces of same size of the data, so that we don't have to worry about how we go about splitting the data and how we distribute it. Then the data is distributed to different locations based on the chunks. If we have 8 chunks and 4 locations, two chunks are displayed on all locations. Preferably one chunk on one location is a good strategy. Then comes encryption data at new location. Once the data is put on the new location, it needs to be encrypted there as well. That is the responsibility of the local systems, or you could encrypt it on your own. That depends totally up to you. This is done for enhancing security, so that even if one person gets access to the encrypted data, it has another layer of encryption added on top of it, so that once the person breaks that encryption, even if the person breaks that encryption, it's not going to work for other pieces of data. Now, to recover the original data, the reverse of the above mentioned steps need to be taken into consideration. For example, the data chunk that was stored in a new location that was encrypted needs to be decrypted first. All of the chunks need to be decrypted. All of the chunks need to be collected in the correct order. They need to be put back together, and then the final decryption needs to happen before we can access the data. On the other hand, we have erasure coding. Erasure coding is like using parity bits for RAID stripping. In RAID, parity bits help you recover missing data if one stripped drive gets lost. So essentially, parity bits work like this. Suppose I have 4 bits I'm storing. All of them can either contain 1 or 0. Parity allows us to determine whether or not parity allows us to determine whether or not how many number of ones are there, how many number of set bits are there. If there are even number of bits, then the parity is 0, and if there are odd number of bits, then the parity is 1. There are options to reverse this, so that even number of bits get a parity of 1 and odd number of bits get parity of 0. That completely depends up to you, but you have to understand the differences between them. Once that's done, even if one of the bits gets lost or corrupted, we can just take a look at the number of bits that are set, and then we can add the data. So for instance, out of the 4 bits, I have 2 ones and 2 zeros. So there are even number of bits that are set, parity is going to be 0. Once one of the data is lost, I check again how many number of bits are there. If, for instance, I have 4 bits, and out of those 4 bits, 1 bit is lost, so I still have 2 ones. That means I have even number of data, and only one piece of data can be added there. That means the missing chunk was 0, so you replace it with 0. That's essentially how RAID works. That's something that is taught to us using in storage systems. But the basic method in erasure coding of data protection is which data is broken into fragments and then expanded and encoded with configurable number of redundant pieces and data and stored across different locations. So that's essentially how it works, very similar to how RAID and parity stripping works. Erasure coding helps you recover missing data in the cloud if the place where the data was stored becomes unavailable or the data gets lost while you disperse your data. In cloud, erasure coding is only used for cold data storage. Cold data is, as far as you are aware, is the archival storage systems. So storage systems that have low latency for high latency for lower costs. And this is because it gets very compute intensive than simple replication across geographical regions. One way to protect your data from being lost when one data center goes down or one server goes down is by copying the same bit of data across multiple regions, so that if one of the data centers completely go down, the data can be recovered from other places. Erasure code like RAID creates parity bits along with chunk data to make it easy to recover the data. A common erasure code configuration is 4 plus 2 erasure code, which means that the data is split into 4 chunks and 2 parity chunks are created out of that 4 chunked data for data recovery. This configuration can tolerate up to 2 node failures. Both of them can either be parity bits or both of them can be data bits, but both of them cannot be parity and data bits. Now, more than two, if there's more than 2 node failure, then there's no way of recovering the data. Now, this is what the process looks like. Firstly, we create the chunk. Data is chunked into 4 parts. Then we encode the data. Encoding the data is a mathematical process in which we keep the 4 chunked pieces that we have as it is, but we create parity bits out of it as well.
Just a quick info, guys. Intellipaat provides CCSP certification training, mentored by industry experts. The course link of which is given in the description below. Now, let's continue with the session.
Parity bits let us take a look at how many ones and zeros are there so that we can understand how the ones and zeros work. Then we write to the disks. Writing to the disks basically allow us to have 6 chunks and we have them be written to 6 different disks so that the failure of one disk does not affect the other one. Now, in case of failure or corruption of data in these disks, we can use mathematical operations to rebuild the missing data. This only works if the number of lost chunks is less than or equal to 2. If it's more than that, then the data is unrecoverable and essentially our entire data is corrupted. This is why it's stored on multiple locations so that even in when worst of worst comes, only 2 of the places where data was stored can go down. Other places might not go down. There's a good chance that that's not going to happen. This is because if the lost chunks had one data chunk and one parity chunk, data can be recovered. If both the parity chunks are lost, then also they can be rebuilt using the existing data. We can just pass it through the encoding process and rebuild the parity chunks. But if both parity chunks and a data chunk is lost, then there is no way of knowing how to recover the data, and we have essentially lost the data that we needed to recover. So that's basically how data dispersion works in a nutshell. Design and implementing cloud data storage architectures. In this, we'll try and understand the individual components of cloud data storage architectures, and we'll try to understand what are the security components that we need to take into consideration when we are using these architectural components. Let's take a look at them one by one. So in cloud data, there are several ways of storing data to cater to different use cases. Using these, you can build your own architectures to satisfy your own use cases. Now, there are also several threats that you need to be aware of, which is what we'll be covering right now. So firstly, let's take a look at storage types. There are 6 main storage types available in the cloud: raw storage, ephemeral storage, volume storage, object storage, CDNs or content delivery networks, and long-term storage. Let us try and understand them one by one. The first one is raw storage. It is permanently allocated disk storage that stores data and exists independently, that is without this running server instances. Basically, you can store some data and then forget about it. You don't need to run a server and attach the disk to that server, so on and so forth. So it works completely fine. It is used to persistently store data such as logs, files, etc. So if you have some data that you need to be stored for a long period of time, raw storage is the best option for you there. Now comes ephemeral storage. Often used to swap files and other temporary storage needs, this storage type is used with infrastructure as a service instances. Basically, it is used with the raw servers, whether they're virtualized servers or real-world servers. And when the instance is terminated, that is either we shut it down or we delete the instance, our instance of the ephemeral storage gets removed with that as well. So it's only for temporary storage purposes. It's really fast, it's really cheap, and it's for temporary storage. Now they are also used as caches and temporary storage locations, which will store data as long as the server is running. So for instance, server logs and all of this kind of stuff, you can run inside, you can have them be stored inside an ephemeral storage. Now, most often a virtual hard drive is something that is attached to a virtual machine or a host. That's what a volume storage allows us to do. Basically, a volume storage is if you have some drive and that drive needs to be partitioned into separate volumes. For instance, when you are working on a Windows system or Linux system or Mac system, you have a disk drive that is much bigger for your need. So you logically partition the drive, that is, create three separate spaces for those drives. In Windows, it's usually the C drive, the D drive, the E drive, and so on and so forth. Depends on how you have partitioned the system. So this is one of those partitions could be considered a volume, and a volume storage is often referred to as a virtual hard drive, which is attached to virtual machines and host systems. It is used to persistently store data and can be attached and detached from already running server instances. Think of it as a virtual USB drive or a virtual SSD drive. Basically, you create some data, you attach a virtual storage or volume storage to that, then you copy the data to that volume, and then you detach the volume, and now it's stored in there. Now, if the server gets deleted also, the data is remaining in the volume storage and you can use it later on. Then there's object storage. File shares accessed via the web interface or real-world APIs. Real-world examples include Rackspace and Amazon S3. If you have ever tried to store some really unstructured data like audio, video, images, any of this kind of stuff on the internet, then on the cloud essentially, then object storage is the storage that you have used. It is not something that creates a file system for you, and how things are managed underneath is not really a concern. You just want a bucket there to be able to throw some data inside it and then forget about it. And this allows you to do that. It is used for storing massive amounts of unstructured data using such as storing photos, songs, or files, etc. Unstructured data is basically data that has no structure to it. There's no pattern. That's nothing. That's just a stream of bits rolling around, and that's what unstructured data is, and that's how you use. That's what you use an object storage for. Then there's CDNs, also called content delivery networks. They are used to store static assets which are replicated over several locations in geographically distant locations. This is done so that your static assets can be accessed by a global audience. To give an example, let's say you deploy a website. It uses certain images, style sheets, fonts, so on and so forth. These are static assets mainly because these do not get updated regularly. They are not dynamic. Different users are not going to get different versions of these files. So what happens is, if you have a server that is serving this file over the internet, and that server is in the United States, and then you are somewhere on a distant location, let's say India, then accessing that website is going to take you a longer period of time because the data needs to travel longer distances than it would take someone, let's say, in the United States. So that's a big problem. In order to overcome this, what happens is these servers are configured in such a way that they access these static resources from the nearest servers available. And these nearest servers are also called edge locations, which are referred to as content delivery servers or content delivery networks. Many of the servers are located and spread across geographically. So one may be in the US, one may be in Africa, one may be in Europe, one may be in Asia, one may be in China, one may be in India. Depending on where you are accessing it from, the nearest server is then asked to fetch the resources so that it's delivered to you at a much greater speed. They are used to store and cache static assets such as images, CSS files, etc. in geographically distinct locations for faster access. Finally, there's the long-term storage. It is also called archival storage. It is used for storing data that is not accessed very frequently, and latency in access is tolerable for low storage cost. Think of it this way. You have some data and you don't use it very often, but since you have stored it inside cloud, you get the opportunity of accessing it really quickly, but that costs you a lot more than it should, mainly because you don't use it that much. You can have the option of moving it to an archival storage system in which this will be stored, and the time that it takes for you to access the file could be a little longer. Let's say that if it takes 1 second for it being served over the internet in the normal storage locations, then in archival it will take 2, 3, or sometimes even 4 seconds. However, that's tolerable because you only use it like once or twice a year, once or twice a month. It's not that frequently accessed, and you get a much lower cost option for storing it inside archival storage. They are used to store data at lower cost and higher lower access speed or latencies, as this data is used less frequently. Think of data such as data logs or something like that, which you use once a month to audit the security prospect of your entire network. In cases like this, these can be moved to an archival storage each year so that the previous year's logs are moved into The archival storage and the current year logs are kept so that they can be viewed at a fast speed. Then the current year, when next year comes, the current year logs are then sent to the archival storage and the new logs are recorded, so on and so forth. Now let's take a look at some threats to storage types. Storage types are an important concept in cloud computing, but there are certain threats that we need to be aware of when we're discussing these storage types. Let's take a look at them one by one. In the ISO IEC 27040 is an international standards published by the International Organization for Standardization and the International Electrotechnical Commission (IEC). The standard describes few threats to storage. These are unauthorized access, unauthorized usage, regulatory non-compliance, DOS and DDoS attacks, modification and corruption and destruction of data breaches and leakages, theft or accidental loss, malware attacks, and improper sanitization. These Let us discuss these threats into a little more detail and understand how you can prevent it. The first one is unauthorized access. As the name suggests, users gaining access or are able to view and manipulate the data that they should not have access to is called unauthorized access. To prevent this, you need to set strict authorization policies and only allow access to resources that are absolutely needed by them. For instance, if a user requests for building an application, let's say that you are an organization and the developers want access to certain resources, you only provide access to those resources that they absolutely need. So a server, a database instance, and a virtual server in which they can connect each other. That's about it. That's all you need for the usage of your app developers. Similarly, other users may have other needs. You need to firstly assess the needs and determine what are the minimal accesses that you can grant them that could work. And once the access is complete, they have done what they need to do, then access revocation policies should also be in place. Then comes unauthorized usage. Users are able to modify, update, or even delete data that they should not have access to. So for instance, if I have created some piece of information and I should be the only person who can access it and modify it, but another user comes in and can do so, then that's an unauthorized usage storage threat. That's a concern that we need to be thinking about. Now, to prevent this, granular permissions should be used and only the required permissions should be granted to the users. Many storage systems allow you to set granular permissions, such as if a user is allowed to just view the data, if they are allowed to manipulate the data and view the data, if they are allowed to manipulate the data, view the data, and also delete the data, and if they are allowed to basically they become the administrator and they are allowed to share this data with other people and can revoke my own access to this as well. So you need to understand the context in which this entire application is running and how the storage systems should be utilized there. For instance, if you have some file and you have shared it to someone, you only need to share them with the permissions that they need. If I only want to view the file, then you only need to share it with me with the viewing permission. And there are options for you to specify the time period for which I can view this. So for instance, for the next 7 days, I can view the file. I can't change it, I can't delete it, but I can view it for the next 7 days. Now comes regulatory non-compliance. Several applications deal with data that is regulation bound, such as data regarding credit cards and payment systems. This data needs to be stored in compliance with the set standards. Otherwise, there is a risk of data breach and leak, and you can be levied with a heavy fine if it turns out in an audit that you are not complying to the regulations. It should be made sure that all the regulations are being properly followed through, and tests and or mock audit should be done, so that when the audits are performed, we can get access to the information that we need in order to determine whether the regulations are being followed. Then comes DOS and DDoS. Many people know these as being denial of service and distributed denial of service attacks. These are basically network attacks in which multiple requests are sent to a particular server in order to take it down. A high volume of traffic is sent to a particular resource or particular server so that it becomes either really slow or it hangs up and dies. In any case, the legitimate users are now not able to access the resource. There are ways to prevent this, such as analyzing the incoming data for patterns such as large amounts of requests coming from the same device or a same network. You can also set policies to deal with the same. Many times, many big companies, what they have done is that they have set systems in place that will determine whether or not a particular IP address or a particular network is potentially performing some DOS or DDoS attack. If that happens, then each request from that domain needs to firstly pass a CAPTCHA test. which specifies whether or not the person whether or not a human is sending the request or machines are sending the request. Do note that this is not just enough for that, mainly because you can't just expect all of this to work just by software. There are several other softwares available for you to install and use for preventing DDoS attacks as well, but strong security policies are the major beneficiaries here. Then comes modification, corruption, and destruction of data. Data in the cloud is protected against unauthorized modification, corruption, and destruction of data. This is usually remedied using data dispersion and replication. So think about it this way: if you have some data and an unauthorized access has taken place, or maybe the data center where the data was stored suddenly crashes, goes down, some natural calamity happened, fire erupted, water came down, something happened, and the servers are destroyed. So the data that you had stored in a remote location where you have no access to it needs to be secured in such a way that it can survive these attacks or survive these calamities. One of the easiest way and one of the most preferred way is using data dispersion and replication. As we have discussed, replication basically means that you store multiple. What you do is you chunk the data into smaller pieces and then you spread those pieces across multiple locations so that they can be rebuilt again. Replication, on the other hand, is just copying the same file across multiple locations so that if one location goes down, the request for gaining access to the file can be transmitted to another server or another place, another geographical location. Data breaches and leakages are quite common nowadays. Data breach and leakage lead to data being accessed by unauthorized users who can then copy and transmit and view the data. To give you an example, when some data gets leaked on the internet, then a simple Google search will reveal the data to be available and to be used. To prevent this, we need to make sure that the sensitive data remains encrypted and HTTPS is used when data is being transmitted over the internet. This prevents data leakages mainly because once the connection is secured and HTTPS systems are being followed, then the data is encrypted over the network. So even if some person is able to essentially listen to what we are sending back and forth, they are not able to decrypt the data, and it's completely up to us to take a look at that. Then comes theft or accidental loss. If a user gains unauthorized access to the data and they can delete the data after creating a private copy of it, and the user may also end up accidentally deleting their own data. It is quite common to users for deleting their own information accidentally. There are several ways of preventing this. First one is make sure that the user is only able to gain access to read-only copies of the data so that they don't accidentally delete it unless they choose to change the mode. Know that this is not enough. Sometimes users are able to change the mode and forget which mode they are on, and if they're in admin mode, then they can delete the data easily. Also make sure that the data access is revoked by the owner or the administrator once the person is done with dealing with data. There are other things that you can do as well, such as multi-factor authentication, to make sure that the user doesn't accidentally click on two buttons and gets the job done that they didn't mean to do. They need to enter some captcha. There are many things that you can do in order to make it difficult for them to delete it accidentally. Then comes malware attack. Malware stands for malicious software, which can end up corrupting data all the resources that are stored on a particular device or on a network. So malwares are quite common, especially in cloud computing. So in order to get rid of them or to overcome this hurdle, the best way is to install antivirus and anti-malware software on your systems and make sure that they are regularly being updated, and then they regularly run their system checks when they are running, so that once the system is being run and malwares do end up attacking, they can be easily caught and can be removed. Also, it is to be made sure that the resources are not exposed to unknown devices or unknown networks so that other people can access and install other software. Finally, there's improper sanitization. After data is deleted or delivered, it should be made sure that it cannot be recovered from any of the resources that the data was stored on. So for instance, once you download a archived copy of it and you delete the data, then it should not be possible for people to look at the cloud computing resources and recover bits and pieces of the data. To do this, you need to use proper policies to destroy data and destroy virtual disks on which the data is stored once the data is removed completely from them. Also make sure that both logical and physical deletion takes place. Logical deletion means that it's deleted from the file tables of the file system that is stored inside the disks. But physical deletion means that the actual bytes get wiped from the disk and it becomes completely clean. so that even if somebody wanted to, they can't recover the data from the disk on which we have performed the deletion. How we can design and apply data security technologies and strategies. In cloud computing, there are several ways of applying data security strategies, so let's take a look at them one by one. The first one is encryption and key management. Encryption is the process of using some process called algorithm to convert some data from its original form, known as the plain text form, to an alternative form known as the ciphertext form. Encryption of data is done using a special random data called the key. The key is a very important concept in encryption. Encryption essentially is a branch of cryptography. It is a cryptographical process. Basically means it hides the original meaning of data. So the contents of the ciphertext cannot be understood by anyone. It appears to be extremely random, and you can't draw any information out of this. Now, the ciphertext is converted back to plain text by using a process called decryption. Decryption is the reverse process of encryption, and it is to be understood that for decrypting the data, the user needs to have the same key that an algorithm had used to encrypt it. There are several algorithms in which you can use a private key to encrypt the data, and then public key which could be multiple keys that person can have. So in this regard, you don't need to share the same key with the person, but in other regards, you do need to share the first key, the same key to the person, so that the process could be reversed. That really depends on you. There are several kinds of keys available for you to use, such as symmetric keys, asymmetric keys, several algorithms for you to use. There's a whole range of things that you can do. The main thing to understand here is this, that keys are important to use, but they are difficult to manage. There are key management softwares that allow this to happen for you. For instance, if you have some key and you want to manage that key, then using a key management software is a great option for you if you have multiple keys and you have multiple data files that you have encrypted. They will also take care of knowing which data was encrypted using which key, and if the data that a key belonged to is deleted, could that key be deleted as well or not? All of this is a complicated process, and there are softwares that will do it for you. Essentially, the process works like this. Plain text is passed through an algorithm and a key supplied to the algorithm. These two features are important. Then this new key that was passed in allows it to encrypt the data and convert plain text to ciphertext. Then that ciphertext, when the user wants to read the data into it, the ciphertext is again passed through the algorithm to decrypt it using the key. Now that key, along with the algorithm and ciphertext, will convert it back to the plain text. Ciphertext is some text that has no meaning. You are not going to be able to understand what it actually contains. So even if a person was able to gain access to an encrypted data, let's say that you have some data stored inside a drive, somebody steals that drive, gains access to it over the internet, whatever it could be.
Just a quick info, guys. Test your knowledge of cloud security by answering this question. Which data may not be suitable for public clouds? A. Legacy application data. B. Mission critical workloads. C. Sensitive data. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
They are not going to be able to extract the information from it because it needs to be decrypted, and it's only decryptable using a certain key, which that person does not have. Then comes hashing. Hashing is the process of converting some data of arbitrary size into a shorter fixed length value called its hash. Different hashing algorithms give you different size of hashes. Usually 64-bit strings are useful, for which there are 64 alphanumeric characters strung together one after the other. Hashing gives us the same data always as a result of the same value. So for instance, if I have some data and I hash it 4 times, I'm going to get the same hash or the same string of finite size. Now it could also be called the signature of the data. Now this is something that many people, when they first understand, find it a bit difficult to understand, mainly because it's not apparent where something like this would be used. So surely you can understand that you can get some data, pass it through an algorithm called the hashing algorithm, and it will give you a signature, if you would call it that, or a hash, if you would call it that, which is a fixed length string And if you were to hash the data again and again and again, the same hash or the same key, same fingerprint will be given to you again and again. Now, where this is useful is something called integrity management. When you have some data and you want to verify if the data has reached you correctly, then you can use hashing algorithms. Many of the online providers of softwares do this. So for instance, if you're downloading some really big piece of software, let's say an operating system, a disk image of an operating system, what they do is that they give you a small fixed length string, also called the checksum string. That string contains is the hash of the data that they have calculated. Now, once you download the operating system's image, you can then again pass it through the hash, calculate its hash, and then check whether its hash, the hash of the file you have downloaded, matches the hash of the file that you just copied. So then, if the hash is matched, then that means that the data has not been modified and you have downloaded the uncorrupted version of the data. If, for instance, even a single bit of information, if a 0 is turned to 1 or 1 is turned to 0, even that change is going to affect the entire hash, and it's going to give you a completely different result. So because of this, you need to understand that the hashes are really important and they are used to check data integrity. Now, another important thing to note is that hashes cannot be used to convert the back to the original data. So just as encryption, when you decrypt the data, you get the original data back. In hashing, there's no such concept. You can't unhash the data, just as you can't convert some large piece of information into a smaller piece and then convert it back to the larger piece. That's just not going to work. So that's how hashing works. Then comes masking. Masking is a very prominent technique. It's used by many online service providers. It is also called data obfuscation. As the name suggests, we essentially just hide some pieces of data that we want to be confidential. It is the process of hiding original data by modifying its content. If you have ever downloaded some official government documentation, then unless you are authorized to have that information, you will be able to download the document, but the data inside it will be masked using X symbols or O symbols or dashes or whatever. This is done to protect the data that can be considered commercially sensitive or even personally identifiable. So for instance, if it's a personal information or it's some commercial data such as the GST number, or could be anything that you do not want people outside your organization having access to. People who should not have access to this piece of information in some records are shown are as the masked data. Suppose you have some database and there are multiple people who can view the database information, since some of the database information is not something that is sensitive while other pieces are sensitive. So for instance, in the case here, the ID, name and email is a sensitive field. Now you can prevent access to the entire row itself. However, it is considered a better option to just hide the data that you don't want people to be able to recognize. So in cases like this, what you do is that you get the data and then you mask it. As you can see, after masking it, we, instead of getting john@example.com, we get the first and the last letter, and the @ symbol is intact. Other than that, everything is hidden behind an X. The name and the ID field are not that sensitive, so you can just show them and it's fine. Although if you wanted to, you could mask those as well. If you want some data to be protected while others not to be protected, then masking is a good choice for you. Then comes tokenization. Now, tokenization is one of the easiest things to implement, and it is very easy to use as well. It is the process of substituting sensitive data elements with a non-sensitive equivalent, which has no exploitable meaning or value, called a token. Essentially, what happens is that this tokenized data can be mapped back to its original form, or the original data stored inside a token vault, which contains the tokens and the original values they correspond to. To give an example, let's say that I have an original value in which I have the ID and name column mapping to 1 and John respectively. I create some tokens. Tokens are just randomly generated things. So now the data is 1, and when we see 1 as the ID, it should be mapped to 7. Similarly, when the name becomes John, we want to map it to Brian. Now, whenever a person gains access to this data, they will only gain access to the tokenized version, and internally we'll be using the original version. The reason why this is useful is because once you are using data replacement techniques like this, even if the person gains access or hacks the information, they're going to get access to information that is completely nonsense. There's no record in our system of someone named Brian with the ID of 7. However, they're going to get it, not realizing that it's fake information, and they won't be able to make any use of it. On the other hand, we will be able to map it back to the original data, and that original data can then be used by our internal systems. So it's a good way of securing the system, so that even if there is a data breach, no one is able to access the actual data that they need to, unless the token data vault is also leaked, in which case you have bigger problems at hand. Then comes data loss prevention, also called DLP. Data loss preventions are a set of technologies that detect potential data breaches. It's not just a single piece of software, it's a group of software. It prevents them by monitoring, detecting, blocking sensitive data while in use, in motion, and at rest. Think of it this way: if you have some data and you are using it, it could be in motion, it could be in rest, or it could be in use while it's being created. These refer to the lifecycle stages of cloud data. And all of these different stages have different security requirements. Now, instead of you having to do it on your own, monitoring the data, detecting and blocking sensitive data, this can be done by data loss prevention systems. Standard data loss prevention systems use technologies like firewall, intrusion detection systems called IDS, antivirus softwares, anti-malware softwares, etc. There are also some advanced data loss prevention systems which use machine learning algorithms, temporal reasoning algorithms, user activity monitoring, etc. These help in understanding how the data is being accessed, if there's some irregularities in the users who are accessing the data, and if so, that the data can be either put into a vault and prevented access unless a person gives some OTP. There are different security policies that can be put into effect after a suspicious activity is discovered. Then comes data de-identification. Data de-identification is also called data anonymization. So if someone is talking about data anonymization, it's the same thing. It is a process that is used to prevent someone's personal identity from being revealed from some data. There are moments when there are times in your life when you submit some data with your consent, with the understanding that the data is not going to be out for other people to use. Your participation in the data collection process and your data that you have provided are going to be completely confidential. In cases like this, we need to provide some mechanism to de-identify the data or anonymize the data. This is usually done when some sensitive data is collected and the identity of the person is irrelevant. For example, when the data is collected from the participants in a medical study. You might end up collecting more information such as the name of the person, the email, if they should be, if they can be essentially contacted, if there's some important stuff that we found about it and we want to call them once again for some another kind of study. Now, in any of these cases, the problem here is that when you publish the study result of the study, you need to publish certain information, and in this publishment, you need to verify and figure out that you are not leaking some personal information that you should have held back on. So, in cases like this, what you can do is you can use data de-identification techniques. Data D is de-identified after passing it through a series of steps, which uses techniques such as tokenization, masking, removal of personal data, etc. Personal data such as name, email, etc. are removed out of this. Now, several institutions and government bodies have their own rules and standards for data de-identification. So it may be that you don't have to do it on your own. Once you store the data inside some system, when you publish the results, the data that you will be given access to is going to be automatically de-identified. But in any case, it's important to understand. As the diagram shows below, a simple data de-identification pipeline in which we tokenize the data and then we mask the data and then we remove the data. So with that, now let's take a look at what else we can do. How you can implement data discovery. So in cloud computing, cloud computing is a set of technologies that can play a big role in data discovery. Data discovery is the process of collection and evaluation of data from various sources. There are several concepts that we need to understand, such as types of data, data discovery techniques, and the issues that might pertain when you're trying to do data discovery. Let's take a look at them one by one. So the first thing that we have to understand is the types of data. Data can be of several types, and discovering these types of data can be different from one another. So the two kinds of data that is available is structured and unstructured. Let us discuss them briefly one by one. Data that is comprised of clearly defined data types and patterns which make it easy to search and comprehend, e.g. data stored in tables, is called structured data. Think of data stored in your databases, your SQL databases, in which you have tables, columns, foreign keys, primary keys, and all of that. That's called structured data. It has a structure to it. You can see the structure repeating in multiple columns. You can search for data quite easily. You can see a pattern. You can comprehend the data easily. Then comes unstructured data, data that has no clearly defined structure and is not easily searchable. Data such as audio, video, images, so on and so forth. At the most basic level, this is binary data. When you take a look at the binary data, there's no structure, there's no pattern that's repeating. The only pattern that you can see is a bunch of ones and zeros are there, but that's not really a pattern, that's just technology that is being used. Other than that, there's not much that you can do to understand how the things are working and how you can make searching and scrolling effective here. Now let's take a look at the different data discovery techniques that are available. So there are several techniques which you can use to perform data discovery, such as metadata, labels, and content analysis. Data discovery using metadata is really especially useful because many of the companies use this. Now, metadata is data about data, such as data when a file was created, column name was created, when the last time these things were edited, what is the last version of the file, the who created the file, when the file was created, when the file was last modified. There's a bunch of data about a file that could be considered information useful for data discovery process. It can be used to find and extract useful information, such as if the data was essentially modified in the last few weeks, that means that it is a useful piece of information. However, if it hasn't been touched in a month, then that means that it could be moved to an archive storage. Maybe we can store it into a data warehouse where this data will be worked on and we'll get some insight out of it. Then comes labels. Labels are descriptions of data, such as the description of what an image contains. These descriptions can be used to group and classify data. For instance, if you have certain images that contain a particular piece of information that is useful to you, let's say that you are trying to build a system that can determine whether or not a particular image contains a traffic light, and multiple traffic lights are going to be inside an image. They can be labeled as containing the classified information or containing the traffic light image, and the other one would be considered not containing the traffic light image. You could go even further and further classify them as when they are containing the traffic light image is one of the lights in the traffic lights on, which one is it red, green, or blue, and so on and so forth. So these are all done using labels, and labels provide very useful information so that we can then discover the data based on the labels that are provided. Then comes content analysis. Content analysis allows us to analyze the documents and artifacts of various formats such as text, pictures, audio, video, etc. This analysis allows us to examine patterns and extract features from the content, such as emotions being shown in a review, etc. If you have some online review that is written and you want to analyze the content and figure out how the content is being structured, what are the words that are used, what are the keywords that are used, does the reviewer review the piece of information favorably or unfavorably? Is he or she happy with the product? Is he or she unhappy, satisfied, unsatisfied, sad, happy, angry, so on and so forth. So this is also very useful. Now comes data discovery issues. Now, data discovery is a complicated process, and as with any complicated process, there are several issues associated with the data discovery process. Let us take a look at them one by one. The ones that we'll be taking a look at are poor quality of data, dashboards, and hidden costs. Poor quality of data basically means that the discovery of data among data that is not correctly classified, that is not correctly cleaned, that contains incorrect information, missing information, that could be a source of a lot of problems. And this could lead to a lot of misleading statistics and misleading facts that may or may not be true because the data is so poor. So poor data can be a major cause of issues. Then comes dashboards. Now, a dashboard is an important data visualization tool in data recovery. However, it can be difficult to build based on the complexity of data and the size of the data. If you have data complexity, data shape is very complex, then visualizing it is going to be really difficult considering the edge cases that you might have to consider, in which data is nested deeply within one another. Now you have to go through each of the nested places to find out whether or not some data is available there, and if there is, then you extract that data, go back up the hierarchy, and then go down. This is going to be really difficult, so it could be an issue, especially if the data comes from a source that you do not control. They can even change the data, and the shape of the data is changed, then your application needs to adapt to that as well. Then comes hidden costs. Costs associated with data discovery are difficult to estimate. These costs estimate may turn out to be underestimated, or hidden costs may emerge if the data is not analyzed properly for the estimation process. So Understanding what kind of data you have, what is the complexity of the data, and how you are going to go about doing this will allow you to figure out what are the hidden costs. Cost may not only be monetary, it could also be time-based cost. For instance, if you determine that it's going to take you 3 months to create a data discovery pipeline there, but it ends up taking you 6 months or 7 months, that means more and more time is being used and more resources of the company are being used here. So it's important to understand how you're going to do that. With that, we have understood all there is to understand about data discovery in the cloud. It is a process that is very important, and these are the issues and techniques that you can use in order to do data discovery. Now let's take a look at data classification. Data classification, or how you can implement data classification in cloud computing. What are the things that you should know before you implement data classification? Now, data classification is the process of analyzing structured or unstructured data and organizing it into categories based on file types, contents, and other metadata. There are several options in data classification, such as mapping, labeling, and dealing with sensitive data, etc. Now, mapping refers to the process of creating links between features and data in a dataset. Suppose you have some dataset that contains images of famous people. The mapping is going to be the features and the data that is considered it contains in the dataset. Or another way of thinking about it is if you have some medical data, then you can create several links between several kinds of data. For instance, one kind of a feature would be if the person is old or new, or you can say old or young. And in cases like this, you can create a link between the old feature and attach it to one particular file and one particular row of data, and then the young people will be given the feature of young. This way, it's easy to categorize and group data together. So for instance, if you have some data that contains just the age of people, but you want to classify them as being old, as being senior citizens, as being young, as being teenagers, as being babies, as being adults as well. So you can generate these features, and then you can just map them to those. Then there's labeling. Labeling is the process of assigning classification labels to determine a class in which a particular row of data belongs to. So taking forward our medical information dataset, let's say that we want to determine a particular person has diabetes or not. If it turns out that a particular person has diabetes, then the data in the row in which it is existing will be labeled as positive. Positive meaning that the person has diabetes. It's a yes or no binary classification. You could also put yes or 1 or 0 as well. A person who does not have diabetes will have 0 in their row. The meaning of 1 and 0, yes or no, and positive and negative are already predetermined because we are checking for a person having diabetes or not. Then comes sensitive information. Whenever trying to deal with data classification with sensitive data, special needs to be taken care of data that is being used for data classification, such as the protected health information, also called PHI, personally identifiable information, PII, and cardholder data. So depending on the kind of data that you're working with, there's special kinds of care you need to take care of when you're dealing with these kinds of data. So these are the considerations that you need to take care of. These are the processes that work with data classification. Now let's see how we can design and implement information rights management systems in cloud computing environment. So information rights management are technologies and processes that protect sensitive information from unauthorized access. For IRM, we have to understand these things, the objectives and the tools. So let's firstly take a look at the information rights management's objectives. Now, as with any technology, there are several objectives that are associated with the information rights management system. But the main ones are data rights, provisioning, and access models. There may be other objectives that you can tack on based on how you want to structure your applications and how you want to deal with the entire data access models. But overall, you have to understand that these are the basic tenets or the objectives that we need to understand. The first one is data rights. As the name suggests, data rights give people authority over their data. They offer the right to access, change, move, and delete their data. Essentially, this is to determine what person has what right over what data. If I create some data, do I then have the right to manage the data, change the data, basically be the administrator of the data? Or does the organization that I am working for has the administrative right and I only have the right of requesting certain permissions for that data? That is covered under data rights. Now, which one of it is for you is something that you need to determine based on the use case that you have. To give you an example, let's say that you want to essentially create a system that works only for yourself, that you're the only person who will be using it, and the data is only going to be the data that you create. So think of it such as a blogging system. In cases like this, it is a good idea to give the employee who will be working with the data complete access over the data. They can change the data, they can add the data, they can delete the data.
Just a quick info, guys. Intellipaat provides CCSP certification training, mentored by industry experts, the course link of which is given in the description below. Now, let's continue with the session.
Whether or not some information is being collected about how the data is changing, what are the changes being made, who are making these changes, when and why, that remains up for consideration, and you can do so yourself. But in any case, data rights essentially means that you determine the people and the authority that they have over the data. So if you're someone who has been using blogging platforms such as WordPress for a company, then and you move it to the cloud, then several of these facts apply to you as well. Then comes data provisioning. It is the process of creating and deleting users from a system. These users have authorization properties associated with them, such as roles, groups, permissions, etc. It may seem really easy to create and delete users, also called provision and deprovision users. However, there's a fair bit of complexity that is associated with it once you take into account the complex networks of attributes that are associated with each user. A user can have different roles such as administrator, viewer, commenter, so on and so forth. And a user can belong to several groups, such as the admin group, the managers group, the management group, and many other kinds of groups. And each person can have several permissions such as being able to access some data, being able to remove some data, being able to spin up some servers and delete some servers, being able to add new infrastructure resources such as servers, load balancers, networks, virtual networks, etc. In all of these, the important thing to understand is that all of these needs to be managed using a permission system. The permission system's primary job is to take care of whether or not you are able to create some data, delete some data, and are the permission applied to you removed once you have been deprovisioned. So if you create a user and you then deprovision that user, do you deprovision their entire identity, or do you deprovision the rights given to them for certain resources? So do you disallow the person from creating new servers, but you keep their identity in your identity management systems? All of these are things that you need to consider when you're designing the security and authorization policies. Which is why it is determined that these systems are very complicated, and they should not be given in hands of every person, because if people don't have the strong understanding of authentication and authorization policies that need to be set for a secure environment, then giving them that kind of access is going to be really problematic for the people who do give them that kind of access. Then comes access models. An access model defines what a user can do and cannot do on the data based on several factors such as their roles, permissions, and the group that they belong to. So in provisioning, what we do is we create the user and we remove the user, and we take care of all the other aspects associated with them. As mentioned before, this gets particularly complicated because of all the values, all the attributes associated with the user, and depending on each use case, we have to determine a particular solution. Access models, on the other hand, determine which role can access which resources, which role can access which data, what permissions are given to a particular user, what groups are associated with particular permissions, so on. To give an example, if you have a cloud computing infrastructure and you are managing the rights and management of everyone, then if a person builds an application and they are the developers, then they should be given access to servers on which the application is being deployed, and the right access to the servers on which the data is being written, or but treated right access. On the other hand, if a person is an administrator, then they should have full access over all of these. Preferably, only one person is given administrator access over all of the resources. If possible, don't give just one person or anyone that kind of access. Compartmentalizing these accesses can be a better option here as well. Another thing to notice is that there are several groups as well. So depending on what kind of permissions you're giving to a group or a person is going to be understandable. Suppose there's a person who belongs to the developer group and the management group, which is to say that they are a developer and a manager at the same time. And in cases like this, they should have access to users' information, they should have access to employees' information, their salary, and so on. And they should also have access to infrastructure resources so that the applications are being deployed and they can take a look at how they're being deployed. However, if the person then gets demoted from a manager to just an employee, then they should be kicked out of a group that gives them that access. Instead of just removing all the accesses for that entire group, we should kick out that person from that group. Again, this depends on the situation that you are faced with and so on and so forth. Now let's take a look at the appropriate tools that we would have to use to implement information rights management. As we have discussed thus far, that it's not easy as it might seem to determine the rights that a person has on particular information in cloud computing environments, and how do people craft their own cloud computing information rights management system depends on the tools and that are available for them. So for digital rights management, we make use of several concepts such as keys, certificates, etc. These concepts require several tools several tools that can perform certain tasks such as issuing certificates, revoking certificate, and certificate revocation. Different tools can do these tasks, or maybe you can create just a single tool that can do all of these tasks. It is to understand that these certificates are cryptographic certificates. It's not a piece of paper that you can just randomly create and copy and paste. They have their own cryptographic signatures, and if a particular action is authorized using a particular certificate, then that person's name is associated with it. And these keys also, these cryptographic certificates also come with keys in order to determine whether or not a person has given their consent for these certificates to be used. Specialized tools that use cryptography to issue cryptographic certificates with securely specifying users' identity and tasks that they need to be permitted to need to be created. Issuing these certificates is a cryptographic process. This is not extremely or lightning fast as multiplying two numbers maybe, or all the other tasks that we perform in a computer-based system maybe. Here we have to understand that these are specialized tools and that they use cryptographic processes. This could take a lot of time depending on the strength of the cryptography that we're using. And so issuing the certificates is a task that is best left on tools, because tools are much better at issuing things and keeping track of things that are issued thus far. Then comes revoking certificates. Certification revocation is basically the process of revoking the certificate so that it cannot be used further. This is also a cryptographic process. Again, cryptographic processes may seem like a very easy term to use. However, cryptographic process are really important to understand. The important thing to understand here is that since these are cryptographic processes, that means that you do not get access to essentially do anything that you want with these things. They are properly secured, and that's why to maintain the integrity and security of the certificates and the meaning of the certificates, we keep track of these certificates using specialized tools. That's why for issuing certificates and revoking certificates, we use specialized tools. Otherwise, all we would have to do is basically just delete the certificate that is inside our database, and that would be it. But since it's a cryptographic process, there's a lot more involved in it. Cryptography uses a lot of mathematics in order to maintain the integrity of a particular system. So we need to take care of that as well.
Just a quick info, guys. Test your knowledge of cloud security by answering this question. Which data may not be suitable for public clouds? A. Legacy application data. B. Mission critical workloads. C. Sensitive data. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So these are the two kinds of ways. Third one is certificate replication. Suppose a particular certificate needs to be issued to multiple people. In cases like this, or suppose a multiple simple key needs to be given to multiple people, maybe it's a public key and we have private key, we have generated multiple public keys and we need to be distributed to each person. This is also a cryptographic procedure and needs to be handled by a special tool. So these are the kinds of things that we need to take care of when we're dealing with the certification using certificates, issuing certificates, revoking certificates, and certificate replication as well. These are cryptographic certificates. They are secure. You can't just automatically create the certificate. Once the certificates are created, then the tasks that these certificates are used to authorize, these certificates are then verified by a verification system, and that certificate verification system then lets go of the task if the certificates are verified correctly. If not, then this is logged inside a a system which will be notified to the data administrator. So with that, we have understood all that is to be understood about information rights management. Now let's take a look at how we can plan, implement data retention, deletion, and archiving policies. So there needs to be policies that deal with several activities performed on data in cloud, such as retention policies, deletion policies, archiving policies, and legal hold policies. Let us try and understand them one by one. The first one is retention policy. As the name suggests, the retention policies are used in order to determine how a particular system is going to retain the data that is provided to us. So essentially, think about it this way: when you have a cloud data policy for retention of certain data, the thing to understand here is this: how the data is going to be retained, for how long it is going to be retained, is it going to be deleted after a while, and how is this going to affect the data's integrity. If someone gains access to a particular data server, is my data encrypted? Is the data that has been retained deleted immediately when I delete it? Is it a logical deletion? Is it a physical deletion? As you can see, there's a lot of policies that need to be taken care of. But retention specifically takes care of how the data is retained. What are the geographical locations where the data is copied? What is the uptime of these geographical locations? Is it encrypted? What level of encryption is there? And so on and so forth. Then comes deletion policies. These specify how to securely delete the data when a specific resource is assigned to a different user. They should not be able to recover the deleted data. Let's understand this using a scenario. Suppose that you are working on a cloud computing system. You have created some data and you have been creating some data on those cloud computing platforms for a long period of time. Suddenly, the application that you used to do is no longer useful and you decide to take it off the internet. Now, for doing that, first things first, you need to delete the data that your users have submitted, such as their email, passwords, mobile number, and many other kinds of things. Now, in cases like this becomes really difficult because once you understand that you have to delete the data, you first have to realize where exactly have you put the data. Is it just in the database? Are the databases storing the data or logs inside some other files as well? Are there some cache files? Are there some servers on which locally the data is stored, so on and so forth. Using this, what we end up doing is we end up creating the policies that will delete the data. So once we end up taking our application off the offline, then we delete the data that is given to us by user by firstly deleting the databases, deleting the servers, deleting the virtual hard drives, so on and so forth. Now, it is to be done in such a way that the data that was deleted could never be recovered by anyone, whether or not they gain access to the same resource. So the virtual server that you had created to host your application stored some data. You deleted that virtual server, but that data is still being stored in some ephemeral storage. When someone creates a new server and gets assigned that kind of it gets assigned the same resources that you did, then can they still recover the data? Can they still find the data or not? These are the kind of things that we need to worry about in the deletion policies of our data retention policy. Then comes archiving policy. These specify how long the data needs to be dormant before it is archived, how long the archiving process needs to store the data for. So to give you an example, archiving is the process when you store some data that is not very frequently used. The dormant data here basically means that it hasn't been used for a long time. Suppose I create some data and I store it in a file. Then I forget about the file and I don't use it for let's say 6 months. Now that you consider some data not being used for 6 months dormant? If so, then in your policy that will be specified, and every time when 6 months pass and a particular file has not been used, then that will be moved to an archived storage. That will cause it to cost less because it's not in the raw storage format, it's in archived storage. Latency of accessing and using the file is going to be more, but since you have not accessed it for 6 months, it's a good bet that it's not going to be used for another 6 months or for a long period of time. In any case, once you archive the data, then you need to understand that how long does the archive data needs to be there. Certain organizations keep some data for archived forever, while others don't like to keep the data archived for any period of time. So in cases like this, we would recommend that what you do is you specify some archiving deletion policies in which you specify if the data has been in archive for 1 year and no one has touched the data, then it's safe to delete the data with the user's permission. Now that permission could be that they send you an email that the cloud service provider, once you log into their console, tells you that this has been the case and would you like to delete the file or review the file. And in any case, these are how these things can be done. Again, you can craft your own policies, you can negotiate with the cloud provider, you can use a cloud broker to do the negotiation bit for you. The important point here to understand is that these are the ways that you can do these things. Then comes legal hold and policies. So some data is highly sensitive in a legal context, which means that some data is extremely legally sensitive, and misuse of that data, unauthorized access of that data, all of that could lead to really high fines and criminal cases against both the person who stored the data and the place where it was stored, if the place it was stored was not in-house. So within specific regions, within specified encryption policies, there are certain regulations that we must follow when we are storing this highly sensitive data. It could be governmental data, it could be medical data, it could be anything. So these regulations need to be followed. For instance, if you are storing some data that is stored inside a particular facility, let's say that you are working with the US government, they have their own specified encryption strategies and how you can encrypt the data, how you would decrypt the data. There are specific procedures that you can follow in order to encrypt and decrypt the data. There are specified regions in which that data should reside, so on and so forth. So there's a lot that we have to be cognizant about when we're learning about cloud policies for legal data. The legality of the situation could be drastic in the sense that once you are working with cloud data policies, you do not know how the cloud data policies are going to be followed. So you can also set up some audits there as well. Several government organizations also perform random audits so that they can determine whether the regulations are being followed or not. So with that, we come to the end of cloud data policies. Now let's take a look at how you can design and implement auditability, traceability, and accountability of data events. Data events are notifications caused by creation, modification, or deletion of data. There are several factors associated with data events, such as event sources, analysis, non-repudiation, and chain of custody. And we'll take a look at them one by one. First thing to understand is that data events are not a new concept. Data events are basically just some metadata that we store about the modifications or changes made to some data, such as when some new data is added to a particular folder, when the data's contents are changed, when that data is deleted, or when that data has its content is replaced by some other contents. All of that is taken care of, and these data events contain information such as the person who changed the data, time it was changed on, when the data was created, when the data was destroyed. If it was destroyed, then this kind of information will be stored. What were the changes that were made, and at what time were the changes made. Using these kinds of metrics, what we can do is we can determine whether or not a particular piece of information was unauthorized, was caused by unauthorized access, was some data accidentally or maliciously deleted by someone, and if so, who was that person, and how can we retrieve the data back? What are the changes that were made by the person so that we can uncorrupt the data and change it back to its original form. All of this is an important tool to understand, and that's why we have cloud data events. Many cloud computing service providers provide these capabilities out of the box, so you don't have to worry about them right out of the gate. However, you do need to understand that these tools are very powerful, and understanding what are the security challenges associated with them can be useful. The first one is event sources. This is a term that is used in software development quite a lot. Event sourcing is a particular kind of software. Event sourcing is the process of keeping track of all the information regarding changes made to some data in a system, and event sources are the software that save or log this information. If you are a software engineer, then you definitely would have worked or either heard of a system like this. It's a very popular system called Git. Git is a version control system. For those of you who are unaware, Git is how software developers manage the versions of the software that they are working on. The new changes that are made by people can be pulled down from GitHub. They can submit their own changes and they can merge new changes to original existing files. Git also keeps track of all the changes that are made to the files, and the labels associated with it are the commits message. So if you have ever written a commit message, you need to understand that these commit messages are the description of the changes that you have made, and the changes that you have made are also kept as records in Git. So if you, for instance, determine that one of the changes that were made and were merged into the master branch are not good and you need to revert back to the original systems, in cases like this, what you can do is you can use you can revert to an original form of the data, or you can revert to the state of the data before it was changed. This is possible in event source systems. So this is why event sourcing is considered such a powerful tool. Similarly, in cloud computing, when data is stored online, the data, when it was created, when it was destroyed, when was it accessed last, by whom it was accessed, who changed its content, what were the contents changed from, what were the contents changed to, and several other information can be kept track of. Again, for example, in Google Docs, you can do this. All you have to do there is essentially you create a spreadsheet and you keep track of the changes that people made and where they made them. This makes it really easy to blame for some disastrous change made by someone based on the event source data that was kept. Now, let's take a look at analysis. Data analysis is also an important aspect of software of data events. These data events need to be properly logged, stored, and analyzed. Once they are analyzed, you can also create dashboards for visualization of the data. What is important for you to understand here is this. The dashboards that are created are not for us, they are for the non-technical people. Usually the data that is stored using event sourcing systems and data events are in text format. They are logged in databases, flat files, object stores, wherever we want to and however we want to store them. And after that, once the data is analyzed, we can determine trends, we can determine people who made the changes, how the changes were made, and we can create interactive dashboards that can take you through the entire timeline of the data that was changed. In cases like this, we recommend that you take a look at data services, and for that, you need to firstly understand the shape of the data that you have logged as the event sources. Then you need to understand how you can create a dashboard. Several services provide these kind of services for you, so you can just basically plug in some data or plug in some service to your cloud service provider, integrate them, and then they will fetch the data from the event sources securely and then create the dashboard for you. Important point to understand here is that even if the dashboards are created, you need to understand that these need to be done in a secure way. So if you are using an external system, then it could be difficult. Many cloud service providers provide their own systems to visualize some kind of data, so you can use those as well. Then comes non-repudiation. Non-repudiation is actually a desirable trait in any secure system. It means that it's a situation where a customer cannot deny authorship of some data and its event. So to give you an example, suppose I have some data and I made some changes to it. Those changes lead to a devastating effect, and now my data is corrupted. The organization that I'm a part of starts blaming cloud computing providers. They can, for instance, tell the cloud computing providers that this is your fault and you need to fix it. Now, in cases like this, what the cloud computing systems could do can take a look at the event logs and just tell that, okay, this is what the event logs say. We can't change the event logs unless it's been made by your organization. That's the policy that we had set. And it shows that one employee of your organization has changed the data. That means that you are the people who need to take care of this. In cases like this, non-repudiation is actually used to essentially specify the order in which, or specify the authorship, which is determined by the event sources. So who made what changes led to what catastrophic failures, what changes led to what successful failure, successful events, so on and so forth. In any of these cases, first thing to understand is that non-repudiation is usually used in many cryptographically secured systems. So it's not something that is new. However, it is to be understood that even if we create any kind of cloud data event system, non-repudiation is one of the key covenants that we need to make sure that we are following. And then comes chain of custody. Now, chain of custody could be a little difficult of a topic to understand right off the bat. Chain of custody refers to the documentation that establishes a record of the control of transfer and disposition of the control of data. Basic idea is this: once you have some data and some people have some access to that data, when that person's access is revoked or is transferred to another person or another ID, that also needs to be checked. And when something catastrophic happens, then this chain of custody, which is I held the custody for the data and then somebody else did and then somebody else did, this needs to be maintained so that in cases of catastrophic failure, data breaches, data leakages, we can get a proper understanding of the timeline of how the data was used, and we can also determine the culprits who might have committed these issues. This doesn't necessarily mean that that chain of custody is the only saving grace. You also need to maintain all the other kinds of non-repudiation analysis, event sourcing, and so on and so forth. However, chain of custody is an important aspect. Chain of custody is such an important aspect that it's not only used in cloud data events, but also in legal withholds. So if you have ever been involved in a legal case, there also chain of custody is something that needs to be established. And in cases like this, all of these things need to be taken into consideration. So just to recap, the things that we have taken a look at thus far is the data events. What are data events? We understood what event sources are, we understand how the analysis of event sources takes place, we understand what non-repudiation is, and we understand what chain of custody is. All of these things collect data that is then audited by auditors, and we determine who was the culprit, who were the people because of whom particular data breach or a data leakage happened. So this is how you implement auditing, traceability, and all of that in your cloud computing system. Data events are an important aspect because they allow us to understand how the data was changed and who changed the data and how we can recover the data back.
CCSP basically stands for Cloud Certified Security Professional. So, guys, if you are planning to shift to the security domain, or let's say you are already working in the security domain, in that case, you should basically think about getting yourself certified in CCSP. Okay, moving forward, let me talk also about the different kind of profiles that you can apply to when you basically become a CCSP certified, right? So let's say you are already one of these profiles or somebody who wants to become one of these guys, then you should actually go ahead and get yourself CCSP certified, because then these would be the kind of profiles that you would be able to apply to. And if you search these profiles on, let's say, Naukri or Glassdoor, you will see that most of them will require you to have a security certification. And no matter which security certification you do, CCSP is always going to be the best. Now, what is the reason for that? So, guys, there are more than 150,000 professionals who are CCSP certified right now. And if you talk about their salaries, then in the US, the average salary of a CCSP certified professional is $138,610 per annum. And similarly, in India, it's 13.5 lakhs per annum, right? So it's a pretty good salary, and it's basically the average salary. So there are people who earn more than this as well, and obviously there are people who earn less than this as well. But in majority, out of the 150,000 professionals that are CCSP certified, this is the salary that they are earning. Right now, this was basically launched in 2015. This was basically introduced, and this is basically a part of the ISC Square certification body. Okay, now in order to get certified in CCSP, you basically have to pass exams, right? And the exams are basically available in 882 locations worldwide, which is basically spread across 114 countries, right? So this basically tells you how widely this certification is accepted, right? And one more stat to back that up: there are 170 countries in which you will find CCSP professionals. So it will not be like that you give CCSP certification and you get stuck in your own country. Even if you have to move abroad for any reason, it could be personal or business, you will find jobs relevant to the certification that you do. Okay, so this is one more reason that why you should become CCSP certified. The first reason I told you was that there are 150,000 professionals who are already CCSP certified. So you will be a part of a network of 1,50,000 people who can endorse each other. Second thing is the salary. The salary is pretty decent. Third thing is it is absolutely viable in most of the countries. There are a lot of places where you can give these exams, and at the same time, there are a lot of places where CCSP professionals exist. Okay, so this is why you should actually go ahead and become CCSP certified. Now let's move on and talk about what is exactly a cloud certified security professional, right? So let's go ahead and understand that. Alright guys, so basically CCSP certification certifies you that you basically know how to apply best practices to cloud security architecture, its design, its operations, and the service orchestration. Now, there are a lot of reviews out there for how beneficial the CCSP certification is, but according to Cloud Computing Intelligence, it was the number one cloud computing certification for 2017. Also, if you think about how many people are like you who want to get certification or who want to basically acknowledge their skill sets of cloud security, then according to a report of Spiceworks in 2018, skills respondents wanted to improve cloud security as a skill set in themselves, right? And this was the number one skill set that they want to improve, right? Also, according to CertMac 2018 survey, CCSP certification could be the next big thing. And it has become eventually the next big thing when it comes to security certifications. Also, it was basically developed by the ISC Square certification body, and I've already told you that. And it was done to ensure that security professional, cloud security professionals which are out there, they have the required knowledge, skills, and ability in the cloud security design, implementation, and architecture sectors. Right? So this certification, the employers can rely on that the candidate who has passed the certification is basically efficient in all the security aspects that revolve around cloud. Okay, so now that we have understood what is exactly the CCSP certification, right, let's go ahead and now talk about what are the benefits, what is in it for you that you should actually go ahead and become CCSP certified. So let's go ahead and discuss that. All right, guys. So the first thing that you will get is career advancement. Why? Because obviously once you get certified, once a organization or a certification body like ISC Square certifies that you're good with security, obviously a lot of companies will now reach you out when you make that public either on your LinkedIn or on the job portal that basically you have uploaded your resume, right? Second thing is, because you, when you will be preparing for this certification, you will be going through a lot of skill sets, right? So at the end of the day, when you will get certified, you will have a versatile skill sets to cater to different kind of cybersecurity needs in different organizations, right? So that's also a good point. Third thing is, it'll give you a solid foundation as well, because not only you will be working through a lot of basic cybersecurity aspects, but at the same time you will be catering to a lot of new cybersecurity concepts which have come into place, right? And because of that, you will have a solid foundation on the top of which you can add on your experience when you will start working in any of the company that basically you will be hired with as a security professional. Finally, you also will be a part of a community of professionals who are also CCSP certified. Now, how that helps is that because of this community, you will be able to endorse each other as people who are certified in the same domain. So let's say somebody's in your community or some CCSP certified professional is working for a company called, let's say, XYZ. So that guy can refer you in his network that anybody who's looking for a security professional who's CCSP certified, I have a friend or I have a colleague who would be interested. Right, so that's how the community works, and that's how most of the CCSP professionals basically make use of the community. Also, you will get better visibility because, like I said, you will be getting certified. You can basically add that in your resume. You can also add that on your LinkedIn, and because of that, you will start appearing in a lot of search results where people look for security professionals. And finally, higher salaries. So most of the people who are in the security domain but are not certified are earning less than 35% of the salary with the same skill set when they are certified. right? So if you are a person who is planning to move to the security domain, obviously it's going to be beneficial for you. But if you are already in the security domain but are not certified, with this certification you can earn an extra 35%, or you can get a hike of 35% once you get CCSP certified. And this has been basically this number we have got from a research or a survey which ISC Square itself conducted. Okay, so guys, these are the benefits which basically can help you when you get CCSP certified. Now, apart from that, ISC Square membership, you will also get a ISC Square membership, which also has a lot of perks, right? For example, you will get a lot of online ISC Square professional development courses, right? You will get free subscription to their security magazines. You will get discounted prices for IC Square events, and this discounted prices is only basically valid for IC Square members. You will also get frequent expert-led webinars, which will basically talk about the latest security issues and how to tackle them, right? You will also be able to start your own IC Square chapter. Let's say if you want to do that, you will also have a lot of volunteer opportunities. Let's say you can basically go ahead and share your expertise with a lot of companies which probably cannot afford you, right? And also you will have digital batches which will be issued to you by IC Square, which you can add in your social media, you can add in your social or your professional network, anywhere you can add it, and that will basically give you again a boost of visibility of that you are CCSP certified. Okay, so guys, these are the benefits of being CCSP certified. Now let's move on and talk about how you can become one. So now let's talk about how you can basically crack the CCSP exam. Alright guys, so now let's go ahead and understand the exam overview. So guys, there are basically 6 domains in the CCSP exam which you will have to master, and all of them have basically been divided or have been given a certain percentage which will constitute towards all the questions which are basically asked in the exam. So you can see that all the domains such as cloud concepts and architecture, cloud platform and infrastructure security, cloud application security, cloud security operations, they're all at 17% distribution in the exam questions, and the 19% of the questions will be on cloud data security, and finally 13% of questions will revolve around legal risk and compliance. Now when you talk about the exam, in total it will have 125 MCQs for you to attempt. You will have 3 hours to attempt these MCQs, and the score that you have to get is 700 out of 1000 in order to pass this certification. Okay, this exam will be available in English, and you can give it at Person View data centers, and this will cost you around $599 if you wish to proceed and give the exam. Okay, now this basically requires a minimum of 5 years of experience in the IT industry. If you want to give this exam, this is the requirement. And apart from that, you should have 3 years of experience in the security domain as well. Apart from this, you should have 1 year of experience in any of the domains that we discussed that will be asked in the exam. And in case you do not have that experience, what you can do is you can basically get a certificate for CCSK, which is basically cloud security knowledge, and this can basically replace that 1 year of experience that you require in one of the domains which will be basically asked in the exam. Apart from that, if you are, let's say, a CISSP certification holder, which is basically for cybersecurity, right? If you are certified in that, then you automatically meet all the requirements that are required for the CCSP exam, which is also a plus. So if you're one of those who have the CISSP certification, then you don't have to worry about the number of years of experience that you have. All right. Apart from that, once you basically get certified, I've already told you, you can get endorsed by your peers, by the other people who are certified in CCSP on professional networks such as LinkedIn, etc., or even the ISC Square membership circle. You can get endorsed over there so that people can refer you in different companies where other CCSP professionals are already working. And apart from that, you will have to recertify yourself after every 3 years to get to be updated with the market. And the way you can get yourself recertified, or the way you can make it easy for yourself, is by earning CPEs. What are CPEs? CPEs are basically continuing professional education points, right? You earn these CPEs when you basically attend various mediums through which the new cybersecurity threats are taught about, and how to basically tackle them is also taught, right? So these CPEs can be earned by attending trainings and events, by volunteering in IC Square's certification exams. You can also, read the magazine that you will get, of course, free of cost once you get certified, and also joining webinars and e-symposiums, right? So these will help you to gain the required skills, the required knowledge, which will be an additional to whatever knowledge you already have, and this will basically help you to crack the certification, which again you will have to give after every 3 years in order to be a CCSP professional. Okay.
Just a quick info, guys. Intellipaat provides CCSP certification training, mentored by industry experts. The course link of which is given in the description below.